Hey, welcome to the next section. So let's recap what we just saw in the last section. We basically saw how to make databases and then how to create tables which are currently empty, which are represented by this box here. Let's say this is a cats table. It's empty, it has no data in it. But in this section, I'm going to show you the tools to insert data into the cats table. Thank you, Blue. That was perfect. So we'll see how to do that. It's a insert command. So we'll see that. And get lots of practice, lots of exercises inserting data into tables. And then the other thing we're going to see in this section, it's not the primary focus, but it's important, is selecting data back out. And I won't remove Blue from the box just yet. She's very paranoid. She loves this box. But the idea is, rather than deleting things, that's for another time, another section, how can we retrieve it out? How can we read it or search? So let's say insert, 10 cats into a box, and they all have different birthdays and breeds and names. I want to be able to run code like select or retrieve the last 5 cats added, or retrieve the names of the Russian blue cats, or retrieve the names of the last, the oldest cat in your database, something like that. Wow, she's having a lot of fun in there. So that will be the goal in this section, is to show you those two commands, inserting data and then retrieving it back out. I'm just going to leave her in there. I can't stand to take her out. All right, well, I'll end it there. Blue's enjoying her box. I'm enjoying whatever this is. Next up, we're going to focus our time on learning to create data. How do we add or insert data into the tables that we've already made? This is another one of the most important and most commonly used commands when you're working with databases. Obviously, it's really important to have a way to get your data in the database. So we'll be using what we learn here throughout the rest of the course. And you could say that for everything else that we've learned so far, but in particular, this command, insert, or insert into. So the syntax here is insert into, and then the name of the table, cats in our case, and then it gets a little weird after that. So let's just focus on that first. Insert into, and then the table name. Then afterwards, in parentheses, we're specifying the columns that we are going to insert. So I'm saying I'm going to give you a name, comma, I'm going to give you an age. And then down here, I have values, which is another keyword, specifying that, okay, I told you I'm giving you a name and an age, here they are. The name is Jetson, and the age is 7. So these do need to match. Name is first, Jetson, age is second, 7. Before we go try it out in Cloud9, I just want to show you that I wrote it this way mainly because it looks best on a slide. You can do it on one line. So insert into cats, name and age, the values, Jetson and 7. Or you can do it like this. And this is actually a lot of people's preferred way of writing it. But this is a huge pain to enter into the shell this way, where you have to space things manually. But when we start working with individual SQL files, where we'll save our own code basically into these separate files in a text editor, and we can space them out how we want, this is definitely a preferable way. But we're going to work with this. I just like this when I'm presenting and when I'm teaching it. It's a mix of readability, but also it's not so laborious like this. Okay, and just to hit this point home, the order that we write these column names matters. So if I say insert into cats, and I say age is coming first and then name, I have to provide age first and then name. So it doesn't matter which order you use, but whatever you establish up here, you have to follow through with. Otherwise, it will try, if you had this reversed, it would try and assign Victoria to age and 12 to name. And that's going to be a problem because we have these strict data types where things are supposed to be numbers and strings. And so if we mix them up, it's problematic. Not to mention that it makes no sense. So let's give it a shot in Cloud9. I'll make some space here. And the first thing we need to do is actually recreate a table, because right now I don't have a cats table. I deleted it because I showed you how delete works. So let's recreate that. Create table cats, and it's going to have name is a varchar 50, comma, age is going to be an int, just like that. Perfect. So now we'll use the insert into command we just learned. So we will insert a new cat, insert into cats, and I'll start with name and then age. And then I'll go to a new line. I don't have to, but I like to. Values. And the values we'll put in, let's say for name, let's work with my cat, Blue, comma, and her age is somewhere between 1 and 2. We'll just leave it as 1. Semicolon, we'll hit enter. We get our query OK. This time it says 1 row affected. You may have noticed that everything else we've done so far has said 0 rows affected. And I think that's pretty self-explanatory. We haven't had any rows of data yet. So all of these commands have returned 0 rows affected. Now we actually have created something. We've added data to a table, and it says 1 row affected. And before we move on, let's insert one more cat here. And this time we'll switch up the order. Insert into cats, and I'll do it on one line, age, comma, name. And then our values, let's say the age for this cat will be 11, and the name will be Draco. All right. And we also get 1 row affected. So a next logical question might be, how do I see the data? How do I know that it's in there correctly? Basically the same thing that you might have asked when we saw how to create a table. How do we check our work? Well, we've created data in a table. How do we check our work? And we'll see that in the next video. Sorry for the cliffhanger. Okay, so we left off with a little cliffhanger, which was we've inserted data. How do we know that it actually worked? And the main reason I made this a separate video is that it gives me a few seconds, a separate opportunity to talk about one of the main dilemmas behind figuring out how to best teach this content, which is that pretty much everything in this course is related and interdependent, or a lot of it is. So here's an example. I'm showing you, or I'm talking about inserting data, but it's really not that great of a learning experience unless you know how to view data. But if I teach you to view data first without having you insert it, there's nothing to view, and so on. So my approach is to try and teach things in isolation, but then kind of bridge the gap and give sneak previews when necessary. So with all of that said, I come from the future here. With a SQL command, you won't actually learn officially until the next section. So for now, you can just copy this. We're not going to talk about really what it does or how it works until the next section. We'll dive a lot more into the select statement. But to view all of our data in any given table, select star from the table name. So select star from cats. And that's all I'm going to say about it for now. Our priority is still focusing on creating and inserting data. This is just going to help us check that it worked. So let's try it. We should have 2 cats in there. Select star from cats. And there we go. We've got name and age. We have Blue, who is 1, and Draco, who is 11. And remember, we inserted these in different orders. So we did name and then age for Blue, and then we did age followed by name for Draco. So that's all there is to this. We know that it works. There's a lot more to using the select command. Probably 30% of this course will be focused on selecting data and filtering it and sorting it and searching and all sorts of different ways of viewing data. But for now, this is a magic little shortcut. So another thing to know about the insert command is that you can use it to bulk insert data. So we can insert 10 different users at once, or we can eventually, once we get to it, we can update 10 different users at once or delete 10 or whatever it is. But for insert, the way that it works is that rather than just giving one set of values, like Charlie, who is 10, we just use a comma separated list. So we tack on a comma, and then we add another one, Sadie, who's 3, and then comma, Lazy Bear, who is 1. A note about the comma placement does not matter. You'll see it. I think what's more logical is actually to put it here at the end of the line, but often what you see is here. I think it makes it easier for you to just visually break things up and to see, okay, here's a new line and here's a new line, but really just a matter of preference. So don't pay too much attention to that. Don't pay any attention to that, actually. What's important is that we have a list, and we can multiple insert all at once. So let's try it. So we have our cats table with Blue and Draco. We will do an insert into cats, and we'll do name followed by age. Now we have values, and our first pair, or our first set of values will be, oh boy, this is the hardest part of teaching this stuff, coming up with the fake data. Let's say peanut, and peanut is 2, and comma, you could have put the comma there, doesn't matter. Let's say the next one will be called butter, who is 4. Yes, I am looking at a thing of peanut butter in my kitchen right now. So that's where that comes from. And lastly, let's do, jelly, who is 7. Just like that, we need our semicolon to end it. Now we get something slightly new. Query OK, 3 rows affected. Awesome. So to check our work, we can just do select star from cats again. And I should be consistent, it doesn't matter, but I'll capitalize the from. Now we have blue, Draco, which were there before, peanut, butter, and jelly. That turned out nicely. And we inserted them all with one command. So later on in the course, when we start working with some more complicated data, what I'll actually do is give you a file that has an insert statement that will insert, let's say, 20 different items into a database, 20 rows. And you'll be able to run that one line and get kind of starter data that you can use. It'll be an easy way to populate your database with data without having to do it manually 20 times. Okay, so that's all there is to multiple inserts. All right, so it's now your turn to give this a try. You're gonna get some practice using the insert command. So we'll be working with people this time. You're going to create a new people table. So actually, this is going to combine both creating tables and inserting data. So the table you'll need to define will have 3 columns. First name that has a 20 character limit, last name also has a 20 character limit, and age, which is a number. So once you've defined that table, the next step is to insert your first person. And for this person, her first name is Tina, her last name is Belcher, and her age is 13. So once you've inserted her, make sure that you've done it correctly. Use that select command to see what's happening. Make sure she's in there. The next person will be Bob Belcher, who is 42. And it's up to you, but I would like for you to try and insert this one using a different order for the values. So if you had said first name, comma, last name, comma, age in the previous one, maybe try last name, comma, age, comma, first name. It doesn't make a lot of sense to do it that way, but give it a shot just to prove that you understand that the order matters. And then lastly, write one insert that will insert 3 different people at once. And that will be Linda Belcher, who's 45, Philip Frond, who is 38, and Calvin Fischoder, who is 70. So insert all 3 of those at once and go ahead and give it a shot. And in the next video, we'll have a solution. Okay, let's take a look at a potential solution for this people problem. So first thing, we need to create the table using the create table statement with first name as a varchar 20, last name varchar with a 20 character limit, and age as an int. So let's do that. I'm just working in the cat app for now. It's fine. We're going to delete this at the end. So we'll start off with the create table and we'll call it people. And the first thing that we'll have is first name, which is varchar 20. Next thing is last name, which is the exact same. And then finally, we have age, which is an int. And then our closing parenthesis. Okay, let's just double check it worked. Let's use describe people. Cool. First name, last name, age, varchar, int. Perfect. So now we're going to insert our first person, Tina Belcher, who is 13. So insert into people. And we'll start off. Let's do first name, last name, age, and then values. and we'll do, whoops, Tina Belcher. It was 13, right? Okay. We hit enter. Just double check that it worked. Select star from people. There, Tina is perfect. Now we're going to insert our second person, Bob Belcher, who is 42, and my instruction here was do it in a different order. So we'll do an insert into people. This time, let's do age, last name, first name. Values. So age was, I already forgot, geez, 42. Last name is Belcher. And first name is Bob. Don't forget our semicolon. Let's do our select again. Perfect. It worked out how it was supposed to. Great. So then the last insert we're going to do is a multiple insert. We have Linda Belcher, Philip Frond, and Calvin Fischoder. Oh boy, this is going to be a lot to remember. Let's start off by just typing out the basics. Insert into people. And we'll do this one with first name, then last name, and then finally age, just like that. Then we'll do values, and we'll start off with Linda Belcher, who is 45, I think it was. And I'll do commas on the new line. And then we'll go with Philip Frond, and he is 45. No, 38. I made this too hard. Lastly, we have Calvin Fischoder. I'm just going to copy Fischoder, who is 70. Calvin Fischoder, 70. Alrighty. And before I forget, we need a semicolon. Perfect. Let's do our select star again. Have to use the up arrow a couple times. And we have Linda, Philip, and Calvin, Belcher, Frond, Fischoder, 45, 38, 70. Perfect. So that's it. And I didn't specify this in the instructions, but let's go ahead and delete the table. So that's drop table people. Goodbye to the Belchers and the other two. And we verify that it's gone. If you tried to do select star from people, we get an error. But if we do show tables, now we only have cats. All the people are gone, just left with cats. Now this video is going to be a slight departure. We're still working with inserting data, but it's a slight side note, which has to do with something called warnings. So to illustrate what I'm describing here, if we tried to insert something that looks like this, so we're going back to cats, and our cats have a name and an age. If we tried to insert a cat whose name is this gigantic string.
This is a cat named Charlie, which is also a human name. In fact, I know a couple of Charlies, fun fact.
If we're trying to put that as this cat's name, and age is just 10, if we do that, let's go ahead and copy this, just so I don't have to type that. Make sure we have our cats table. Let's do describe cats. Okay, so name and age. Remember there's this restriction here of 50. I'm just going to paste that and put a semicolon. I get something that says query OK, 1 row affected, 1 warning. Just to double down on that, I pulled it out into a separate slide. 1 warning. Oh my gosh, what's going on? Well, if we wanted to know what that warning was, we can use this command, show warnings. So we'll go back and type show warnings. And I want you to pause and think, what is the warning? If you were to guess, obviously we haven't talked about it yet, but what do you think I'll see? And the answer is I get a warning here that says data truncated for column name. So that corresponds to name here, which had a limit of 50 characters. and this is more than 50 characters. I can't remember how much it is, but it's more than 50. And if we look at cats, you'll see that first of all, our table gets a little messed up here, but the string for name gets cut off after this cat is named Charlie, which is also A, and then the rest is gone. So it's not like it's hidden and it's not displaying, it's just not stored at all. So that's important to note. So that's one warning that we saw there, and that happened when our data was truncated. Can you think of another warning we could generate deliberately? What's something we could do that would give us a warning? So pause the video, or don't, but try and come up with something based off of what we have currently set up for cats. How could we insert something that would give us a warning? All right, so what I was imagining is that we could try to insert something where we mixed up a data type. So let's say age, instead of being an integer, we passed in some text, random gibberish. That should generate a warning. So let's try it now. Insert into cats. We'll do name first and then age. And name will just be Lima, why not? But age will be gibberish, like that, which is not a valid integer value. We'll hit enter. We get one warning, and we can view that warning with show warnings. And this time, it's a different warning. It says incorrect integer value. So the last one we saw said that name was truncated. It was too long. This one is telling us that incorrect integer value for column age. So then here's a second thing for you to think about. And you probably, you'll just have to guess, but what do you think is stored inside of age? Any ideas? Well, if we do a select star from cats, we can see we have Lima, whose age is 0. So in this case, if we screw something up, if we pass in some invalid data or a string instead of number, it will automatically set age to be 0. In a little bit, we'll see ways of changing that default. But for now, it's 0. Okay, so that's it for warnings at this point. Just be aware that if you do see one warning or two warnings or however many warnings after a query, type show warnings and you'll be able to see your answer. However, actually, I forgot to mention this. If we do something invalid, so let's do the same thing, but instead of Lima, I'll call the cat Cusco. I can't remember if there's a Z in that. I don't know. Well, we'll assume that there is. So Cusco, with this crazy gibberish, should give us a warning. But if I do something in between, like select star from cats, and now I do show warnings, nothing. Our warning set is empty. So this is just something to be aware of. With that said, when you're creating applications using MySQL, that application, whatever you're using, let's say we're using JavaScript or Ruby, that will have ways of handling these warnings and letting you know. But when you're working in the shell like this, you have to use the show warnings command. All right, that's all there is to warnings. In this video, we're going to answer a simple question. Back when we typed describe table names, so describe cats, what's up with this part? What is this null column here in this little table? And why is there 2 yeses for name and age? So this video is all about null, the concept of null, and working with null in SQL. So to start off, let's talk about what null means. Null basically means that the value is unknown. It's SQL's way of saying, I don't know what this is, or there is no specified value. An important note is that it does not mean 0. Some people often think null means 0. It doesn't in this context. So to illustrate the significance of these having a yes here, it basically means that these are permitted to be null. It's okay if they have an unknown value. And that happens by default. To illustrate, though, that is the case, here's a little bit of code. Right now, we could run this command. We have a cats table with name and age, but we could do insert into cats and only specify a name, And in this case, I used Alabama. I'm not sure who names her cat Alabama, but you could probably say who names her cat Blue, which is what I named my cat. So we could run this command, and age has no specified value. So in fact, let's try it right now. Make some space, insert into cats, name, values. What is this siren? Alabama, just like that. We don't get any warnings or anything saying that name or that age is empty, nothing like that. Now if we do select star from cats, you'll see that we have a new cat whose name is Alabama, but age is null. And again, that's because we have null as a permitted value, or it's technically not a value, but age is allowed to be null. So is name. So I could do the same thing, or an even more extreme version. I could run this. Insert into cats, nothing. Values, nothing. And if I did that, take a moment to guess. Insert into cats, nothing. Values, nothing. What do you think will happen? Let's do a select star. Now we have cat null, or name null, age null. So then the question becomes, how do we prevent that? How do we require that name is not null and that age is not null? And the answer is not null. So what we can do is specify when we actually define a table that something, let's say a field like name, is not null. And we use this syntax right here. So here's an example. For a cats2 table, and I'll be using this convention, cats2, cats3. So in a cats2 table, our 2.0 version, when we define it, we would say name is varchar. This time I used 100, but the limit doesn't matter really, followed by not null. So that means that it will not be permitted to be empty. And then age is also an integer, age is an integer who is also not null. So if we try that right now, I'm going to create a table, cats2, and we're going to have, and I'll do this on separate lines. Name is varchar 100. It's okay. This one you can have longer names. And then we'll have not null, followed by age is an int, also not null. We hit enter. Now let's start off by using describe cats2. This time, under null, for both fields, says no. So that's one way to tell that these are not allowed to be null. And just to emphasize this, I made a slide. Notice the difference here. So now let's actually put it to the test. Let's try to insert into cats2. And this time we'll only do name, and we'll leave off age. And then we'll have values. And name for this one will be Texas, in keeping with the state theme. Okay. What do you think will happen? Insert into cats where age is not allowed to be null, but we're not specifying age. So it says query OK. We didn't get an error message, and we got a warning. So let's do show warnings. Warning, field age doesn't have a default value. So what it's telling me is that I left age off. I didn't specify it. So what it was going to do is make it null, but then, oh no, it's not allowed to be null. So I need to go find a default value, and there's not a default value specified. So if we look, and you can probably guess our next video will be on default values. But if we do select star from cats2, you can see it automatically defined 0. So in the next video, we'll talk about why that happened. But the way that int works, if it's not allowed to be null, you don't have a default, it's going to be 0. Now let's try the same thing with insert into cats2. And this time only age is specified. And age will be 7. I get the same query OK, one warning. show warnings. This time it says field name doesn't have a default value. Let's do our select star. Notice what we get right here. Earlier, see how far back I can go, we had null when we didn't specify a name, when we inserted into cats, just regular cats, not cats2. But now, when I don't specify a name, it doesn't say null. And this is an empty string. So there's a difference. Null means that there is no value at all. We didn't specify. Empty string is just a type of a varchar that just has nothing in it. So you can think of it as this, basically. Okay, so next we'll talk about how we specify these default values. Okay, so we're moving on. In this video, we're talking about default values. What's up with this part right here? Default. So as we talked about a little bit in the last video, it's helpful to be able to decide or to set default values. So if something is not specified, that there will be a fallback. And here's how we do it. We use default, so you can see both of these when we're defining a table. Default, and then we specify default. So for name, if you leave off name, I just said, okay, we'll call it unnamed or name to be determined. Sometimes if this is a cat shelter, in the real world, sometimes they decide on a name a little bit later once they figure out the cat's personality. And then for age, if this is more of a silly example, but if we wanted to, if we didn't specify age, we could always set it to be 99. Not sure why, but for the sake of this exercise, we're going to do that. So let's give it a shot, remaking a new cats table, cats3. Okay, here we go. So create table, cats3, and I'll do a new line here. And we will have name, varchar, let's do 20, even though my slides say 100, it's okay. Default, and our default will be, let's see, no name provided. How about that? It's important that whatever you put here matches this data type. So we couldn't say the default is the number 100. And then we'll have our comma, age, and age is an int. Default should be 99. Perfect. Close that. Now if we do our describe cats3, here we go. So we have default, no name provided, and default 99 for age. Awesome. Okay, so now let's give it a shot. Let's do insert into cats3, and I'll do age only and no name. And age will be, let's do 13, just like that. What do you think will happen? I'm going to insert a new cat into cats3, which is right here, only providing age. And name has a default value of no name provided. Okay, I did it. Now let's look, select star from cats3, and I get no name provided. Perfect. So we have a default value that's working great. We could do the same thing for age. Feel free to skip this if you feel like you know exactly what's going to happen. Let's leave both off this time. Insert into cats3, values. Now when we select, we have another unnamed cat, this time who is 99 years old by default. So the next thing that I want to talk about, here's another version of creating a table for cats4 this time. And I combined not null alongside default. Otherwise it's the same. So we have name, varchar, default is unnamed, age, int, default is 99, but I added in not null. And as I wrote here, you might be thinking, isn't this redundant? Because if we have a default value, it's already saying it won't be null. If we go back and we look at cats, regular cats, if we do an insert into cats, just like this, and if you can remember all the way back to cats, we have no default provided. And I do select star from cats, we get null, null. There's no default values. And then when we have our cats3, when I insert something like this right here, insert into cats3, it's totally empty. We have those defaults. So when I select star, from cats3, we get no name provided 99. So why would we want to add not null? And the answer is that we could still manually set something to be null. So if I did that here, let's do insert into cats3, and I'll do name and age, values, and I will say there's no name. All right, let's say name is, what's another state? Montana. It's not too bad for a cat's name. Great state, by the way. And we'll leave age as null, explicitly null, just like that. Let's do select star from cats3. And you can see that there was nothing stopping us from setting age to be null. All that we have is a default value. If you don't specify something, it will be 99. But you're allowed to say null. I'm allowed to say this is explicitly an empty value. Okay, so that's where this comes in. Name, varchar, not null, and a default. And I won't make you sit through me typing that whole thing, so I'll just copy it. But to walk through it again, same thing here. Same with the default, we just added not null and not null. So let's go ahead, paste this in. This is cats4. This time, if I do describe cats4, we now have null is no on both, and we have a default on both. So we're almost there, I know. It's been a little bit of a long video. Let's do a insert into cats4. And we will specify name and then age. And this time, if I do values, and I say name is, what's a name? Let's do Cali, fine. Sort of a state name. And age is null. If I do this time we get an error. So not just a warning, but an error saying it cannot be null. And that's what not null specifies. So important to note that. You'll use not null pretty often. It's a way of basically requiring that something has a value, but also saying that it's not allowed to be null itself, which I also included as a slide here. In cats3, we could manually insert something as null. Okay, as you can see, the slide says we have one more thing, and that is true. We have one more thing to cover here before we do our final exercise in this section. So in keeping with this pattern, what's up with this key column here? And it's empty. There's nothing for name or age. What does this mean? So to dive into this, and this is actually something we are going to come back to quite a ways down the line in this course, but we'll experience working with key for the first time in this video. So to illustrate the problem, right now, I could do this. I could insert identical data, Monty 10, Monty 10, Monty 10, Monty 10, and so on. And we've already seen this, but just to prove that to you, if I just work with cats, let's do select star from cats, and this is true about any of the cats tables we have. You can actually already see we have two cats that are identical, null and null. But I could also do something like insert into cats, name, age, values, and this one will be called Helena, and Helena will be 6, or Helena, however you say it. We can do this, and we can do it as many times as we want, and there's going to be identical data in there. As you can see, we have 5 identical cats. So why should you care? Why is this really a problem? And there's a couple reasons, but it comes down to the fact that we want all of our data to be uniquely identifiable. Even if it looks the same like it does in this case, we assume that these are separate cats. If they are in fact one cat, then this is just in error. We don't want to have this many entries. But imagine we actually have 5 cats named Helena with an age of 6. They are unique and individual, and we want to be able to keep track of them. And right now we can't. There is no way to uniquely refer to this. So in a case like here, where we have Alabama, who is null, age null, and then we have null, who is age null, there's a way of telling these apart. Even though they both have age of null, I could tell SQL, and we don't know how to do this yet, but I could say, give me a cat whose age is null and whose name is Alabama. And that can get me this. But there's no way for me to get this cat and separate it from this cat, or this one and separate it from this one. And that's really a useful and important thing, and it's actually a really fundamental part of working with databases, is having things be identifiable. When you're signing up for an account on, let's say, Twitter, and you're trying to make a username, there's a reason that you can't just make the same username that already exists. I wish that I could just go and make my username Colt, but somebody already has that. And it's not just about keeping it simple and not being confusing for users, because obviously it would be confusing if there was, one Colt and then another Colt and they're both tweeting. How do you know who is who? But actually in the code, that's hugely problematic, because there's things like when I log in, I type my username and it's going to go to the database and try and find a user with username Colt, and then it's going to match my password. But if there's 2 users with username Colt, then what does it do? So in that case, you're not allowed to have separate usernames. But there are times when we have data that looks the same. Like hypothetically, we could have 2 cats named Helena, age 6. Or maybe a better example, we could have a couple of cats, if we go back here, where we have no name provided. They're unnamed, but they're unique, different cats. How do we know? And the easiest way, and what we'll do and what pretty much everyone does, is assign an ID, a unique identifier. So you can see here I added a new field, cat ID, and every cat is given one of these IDs. So now, rather than saying, I want to select Monty from this database and getting all of these, I can say, I want the cat with ID 1 or ID 3, and they are uniquely identifiable. All right, so there's a precise term for this, primary key. So a primary key just refers to something that is a unique identifier on a row. It's a way of identifying something, and you know that it will be unique. Just a heads up, we will see another type of key later on called foreign key. Those are both keys. Don't worry about it. But primary key just means that whatever field we assign, whatever we make the primary key, so in this case, we would make cat ID a primary key, means that it has to be unique. So let's see how we actually assign one. So I'm creating a new table here. And I know it's a little bit longer than what we've seen, but a lot of it is very, very similar. So we have unique cats. It's just the name of the table. I got tired of cats 1, 2, 3, 4. So unique cats. We have name and age, but we also have cat ID now. So cat ID is an integer, and we can't have cat ID be null. We definitely want there to be something there. And then this is the new and important piece. This is just another field. This isn't technically new conceptually, but this is primary key, and then we give it the name of a field. So we want the cat ID to be unique. We want it to be the unique identifier, so we just pass it in here, cat ID. So let's try this out. I'm just going to copy it over just to save you time, so you don't have to watch me type the whole thing. Here we go. Create table, unique cats, a cat ID, name, age, and by the way, that cat ID you talked about earlier is a primary key. All right, so now let's do describe unique cats. And you'll see a couple things. We have cat ID now, because we had this line here. But we also, under this key column, we have primary, or pri, but it means primary key. So cat ID is a primary key. So how do we know? Well, let's insert into cats, or unique cats. We'll do ID, name, and age, just like that. and then we'll do values. And we'll start off with an ID of 1. Name will be Fred. And age will be 1. Let's do 2. Fine, 23. Accept the typo. Okay, hit enter. Oh, we have a problem. I just referred to ID. It should be cat ID. Silly mistake. So let's fix that. Cat ID. Okay, so now just double check our work. From unique cats. Cat ID is 1. All right, so we could do the same thing. Change this to 2. And instead of Fred, let's have Louise, who is 2. 3. We hit enter. Same thing. I think you get where I'm going here. We can keep doing this. However, and this is where the primary key part comes in, I could now say insert into unique cats, cat ID, name, age. What if I tried to make another one with ID 1? And this one is called James. Just like that. I get a new error. Duplicate entry 1 for key primary. So this is saying, wait a second, you said it's a primary key. I cannot have a duplicate entry. You cannot have something. The whole point is that ID is supposed to be uniquely identifiable. Well, that's a problem. So it doesn't add it to the database. So that's really, really important. And IDs are not the only thing you can make primary keys. I gave that example of username, which is something we'll come back to later. You often want to make a username a primary key so that you can't have more than one account with the same username in your database. And so all that you would do is, instead of saying primary key, where's that? Cat ID, you would say primary key username or whatever the name of the field is. And then if I tried to insert something with an already existing username, I would get the same error here. Okay, one more thing to talk about, which is it's kind of annoying to have to manually specify this ID. It's more than annoying, it's impractical. I mean, are you just supposed to know where you left off? 1, 2, 3, and every time you insert a cat, you just have to know what the last one was? It just doesn't really work. It's not even in this shell context, but especially not in a real application. You can't, and it's just a pain. So there's a way around it. Our code gets longer, I know, but all that's added here is this, auto increment. So it does what it sounds like. It will take cat ID and it will automatically add 1 to it every time a new cat is created. So we no longer have to specify cat ID is 1, cat ID is 2. It will just do it. We just leave off cat ID entirely. And everything else here is the same. So cat, unique cats 2. I'm just going to copy this over, make some space, hit enter. And before I show you that it works, if we do describe unique cats 2, you'll notice that we also have auto increment here under extra. So it doesn't get its own field, but it's considered extra. So now let's try and insert something into that. Insert into unique cats 2. And we'll do name and age. We don't specify cat ID anymore. Values. And let's see, seriously, the hardest part of all of this. Let's go with Skippy. Once again, I see some peanut butter in my kitchen. And age will be 4. Just like that. Now, if I do select star from unique cats 2, cat ID is automatically 1. And to prove to you that it's auto incrementing, let's change this name to GIF. And we select star again. And now we have 2. So this solves 2 problems. One is that it's annoying to have to manually type those IDs and keep track of what number we're on next. But also, I can now have duplicate cats as far as name and age, which is our whole goal from the get-go. So I can now do another GIF and another GIF again. And this time, let's do a Skippy as well. Now select star from unique cats 2. And you can see we have Skippy here who's 4 and Skippy here who's 4, but they have different IDs. Therefore, they are unique. Same thing with 3 GIFs. Perfect. Alrighty, so that concludes all the new stuff in this section. Now you're going to get a chance to put it in action, to actually practice it, and to write your own bit of code, create your own table that looks a little bit something like this. Okay. All right, so it's your turn to put some of this into practice with a single exercise. It should be pretty quick. All you need to do is define a single table. So here are the demands. Well, demand sounds a little strong. Here are the requirements. Define an employees table. So let's say we're a company trying to manage some employees. We'll definitely need more data than this to actually make it operational, but for now, this is all we need. 7 different fields, 7 columns, ID, last name, first name, and middle name, and then age and current status. And actually, I can't count. This is 6. So ID is relatively self-explanatory. It should be a number. I'm not telling you the data types, but you should know at this point what they are. So a number that automatically increments. It's mandatory, so it can't be left off, and it's a primary key. Last name and first name are both text, which isn't the data type. Again, you need to use the actual term, and then neither of them can be left blank either. They're mandatory. But middle name, while it's also text, it isn't mandatory because not everyone has a middle name, so we can leave that blank. Then we've got age, which is numeric, and it is mandatory, can't be blank. And finally, current status, which is essentially like their employment status, if they're employed or if they're fired. And it should be mandatory, so it can't be null. But if no status is provided when something is inserted, it should default to employed. So we'll have 2 statuses, employed and terminated, or fired or something. I guess terminated is more professional. And so it should just default to current status is employed if nothing is provided when it's inserted. Okay, so go ahead and define this table, type it out, try running it to make sure it works, and then try inserting some data as well to make sure that it works. Okay, if you want a solution, have it in the next video. All right, so if all you care about is the solution, just check out the code following this lecture or pause the video. You can see the solution here. But I'll go ahead and go through the process of typing this out very quickly. I'll kind of speed it up. So what I like to do is start by defining the rough skeleton of what we need in a SQL file. So we need a create table employees, and then within that we'll have ID, we'll have first name, we'll have last name, we'll have middle name, and then we have age and current status, just like that. And then we can fill in the data types. So we know ID is an integer and age is an integer. And then these are varchars, for our cars. Let's say 255. Somebody may have a giant name. And same for current status. So then the next thing that we could do is focus on ID, which we know needs to auto increment. And we also want it to be mandatory and a primary key. So mandatory means not null. And a primary key, there's actually 2 options. The first one is to do this. And the second one, just duplicate this, it's also in the slides, is to add it on the end here. We don't want that underscore there. There we go. So these will do the same thing. But of course, we're not done. So the next thing would be first name. And first name is just mandatory, as is last name. So we'll just add not null and not null. Middle name we can leave alone. Then we've got age, which is also mandatory. And then finally current status, which is mandatory, but there's also a default value. So we want not null, default employed. And then we need to make sure we have all of the correct commas here. Just like that. Add our semicolon as well. Copy it. And let's see what happens. All right, so it looks good. We can describe employees. And then if we wanted to, let's just do a single test insert to make sure our default value works and our auto increment works. So we'll do insert into employees, and we'll do first name, comma last name, comma age, and that's it, because everything else either has is allowed to be null or has a default value. and we'll insert someone with the name of Dora Smith, I guess. And let's say she is 58. Okay. Copy that, paste that in. Let's do a select star from employees, just like that. And it looks good. We've got an ID auto incrementing at 1, first name, last name, middle name is null because it's allowed to be, age is 58, and current status is employed because we didn't specify one and we have a default value. All right. So again, the other solution here is just to put primary key on the same line when you're defining the column. I prefer to do it that way, but you'll also see it done this way. Both work. All right, that's it. Hey, welcome back. If you're looking at my desk right now and you're asking, wow, why is there so much CRUD on it? Well, you're on to something. This section is all about CRUD. Yeah. So CRUD is an acronym. It stands for 4 things: C-R-U-D, create, read, update, and delete. And they are the 4 basic actions that we want to be able to do to our data. So we've actually seen 2 components already. We've seen how, let's say we're working with users. We've seen how to create users with the insert command. We've seen how to read users, take them back out, spill the milk out of the database. That is the read section, which we did with select. Now we also are going to review more about select and insert, but primarily we're going to see how to update and delete information. So how do we change something in our database if we made a mistake, or let's say a user changed their password. They clicked a forgot my password link and they want to reset it. We need to change it in the database. And then delete, let's say our user decides to leave our site for some really bad reason. We can delete him or her. So that's the focus of this section. We're going to have a ton of exercises because we're seeing a lot of commands. And now that we have those 4 commands in place, we'll be able to go do a lot of stuff. They're kind of the fundamental 4 things of any database or any data. So tons of challenges coming up. Look forward to that. And I'll see you basically in the next section when I have to do another one of these videos. See you in a bit. Alrighty. So in this section, we're going to focus on the basics of something called CRUD. So it's an acronym, C-R-U-D. And it stands for create, read, update, and delete, or destroy, some variation of that. The idea is that these are the 4 main operations that we perform on our data. We've already seen how to create data. When we have a database, we want to be able to add data in. We want to be able to search back or read it back out. We want to be able to update it, and then also to delete it. Those are the 4 most important and most common operations that we'll do. And CRUD itself, the acronym, is not particular to databases. It's common in other facets of programming and web development, but it's a nice acronym that fits what we are trying to do here. So what we're going to do is step through all 4 different operations. And we've already seen create. It should be review, hopefully, which we do using insert into. So going back to our cats, we have things like insert into cats, name and age, and then the values, taco and 14. So we won't spend any more time talking about create in this section, but we'll be using insert into throughout the rest of the course. But really what we're going to focus on here are the other 3 operations. So how do we read data out? How do we search? How do we find things? How do we update data if we made a mistake or something changes? And then how do we delete data? How do we delete everything from a table, and how do we delete 1 or 2 things at a time? So that's really what this section will focus on. And we'll kick it off by talking about reading data out. Okay, so before we see any new code or new commands, I want to clean up the data that we currently have. If you remember, we kind of added a bunch of different cats databases. We have cats and cats 1 and cats 2 and cats 3 and so on. What I want to do is delete the original cats table, and then we're going to remake it, but with a few additions, because our original cats table was the most basic. It only had name and age, but I want to add some other data in, like an ID that auto increments and so on. So basically, we're just going to remake the cats table and add new data in. So if you want to make a bit of an exercise out of this, the first step would be to delete the cats table. So do that now. And the command, if you want to see it, is drop table cats. So let's do it. Drop table cats. Oops. There we go. And now that we've dropped the table, we want to recreate the table. So this is what we want here. We're going to have a cat ID, integer not null, auto increments. We're going to have a name, that's a varchar, a breed, that's varchar as well, an age that is an integer, and cat ID is our primary key. So if you'd like, go ahead and type that out, or just copy it, paste it in. Perfect. Of course, we could make sure it worked. Describe cats. There we go. All right, so the last step here is to add new data in. And I would like for you to have this same data because we're going to use it throughout this section. There'll be a couple of activities and questions, and it will be much easier if you have the same data as me. So we've got 1, 2, 3, 4, 5, 6, 7 cats. Each one has a name, a breed, and an age. Some of them, there's a couple of Maine Coons, a couple of Tabbies, and a couple that have the same age, which we will use in just a little bit. So copy this, or if you're a masochist, you can type it out, paste it in. Perfect. And now we have 7 cats in our database, 7 rows. Okay, so now we've prepped our data. We've deleted the original cats table, remade a new special cats table with some more interesting pieces of data, and then we've inserted data in there as well. Awesome. Next, we're going to move on to talking about searching or reading data out. So we're moving on to the R of CRUD, which is read. How do we retrieve and search data from a database? And we've actually already seen this. The magic command is select. So remember when we were doing this earlier, select star from cats. I told you not to worry about it too much because we'd spend more time on it. And it was really just something that we needed to have to check our work at that time when we were inserting data. But we didn't actually talk about how it works, what the star means. That's what we're going to do now. So the star in select star from cats means give me all the columns in the cats table. So we're asking for the cats table, that's the from cats, and in that table we just want everything that we have. So in our case, that means cat ID, name, age, and breed. We want all of them coming back to us. So let's do that now. Select star from cats. You can see we get cat ID, name, breed, and age. And we also get every single cat. No one is missing. These are the 7 that we inserted. So that's the basics of select star, which you'll use often just to check things out. But we can also get more specific about what data we want back, which is where the select expression comes in. Basically, there's a way for us to specify what columns we want in particular. I only want the ID, or I only want cats' names and age, but not the breed. So to do that, rather than saying select star, we can do things like select name from cats. And if we do that, select name from cats, what do you think the table will look like? It looks like this. We only get name. So it gives us all 7 names, but nothing else. We could also do select age from cats. And hopefully this is what you expected. We just get a bunch of ages. And just to hammer it home here, we could also do a select, let's do cat ID from cats. And we get 1, 2, 3, 4, 5, 6, 7. Okay, so that's useful enough, but oftentimes we want more than one piece of data, but we don't want everything. And that's where this comma separated list comes in. So this whole thing is the select expression. We're saying select name and age from cats. So we can try it now. Select name, comma, age from cats. And what do you think we'll see? So we get a table with name and age returned back. So there's no limit on that. We could do name, age, comma, cat ID, comma, breed, which would be the same thing as select star. We could do name, age, and breed, or cat ID and name and age, and so on. I think you get it. We can mix and match whatever fields we want back. So just to illustrate my point, let's do a select cat ID, comma, name, comma, age from cats. And we hit enter. and we get those 3 fields. Notice we're missing breed, but we could just go add that in if we wanted. And notice that the order matters. So I said cat ID, then name, then age, then breed, and that's what we get. But if I just did a select star, it uses the default order, which is cat ID, name, breed, and then age, which is just how we entered it when we created the table. So I could reverse it if I wanted to by select age, then breed, then name, then cat ID from cats. And there we go. Okay, so that's pretty much all there is to the select expression, for now at least, where we're just specifying exactly which columns we want, or we can default and use the star, which will give us all columns. Okay, so what we've seen so far allows us to specify what columns we want, name and age only or only ID, but it still gives us every single result in the table. So if we have 10,000 users in our database, if we wanted to select one, we don't have a way of doing that right now. We only can select all of them, which really is not that useful. And in fact, most of the time when you're selecting things, you're doing it deliberately and you're trying to find particular pieces. You're not just trying to check in on your table, make sure everything's okay. You're usually trying to, let's say, sign someone in if it's an application. You're trying to verify, find someone by their username and check if their password matches that they entered into your website. Or something like that, where you're searching for specific data. And to do that, we need to use what's known as the where clause. So it's another magic keyword, where, and it allows us to get specific. It allows us to say, I want all cats who are 4 years old, or I want all cats who are tabbies. And those are very simple examples, but later on, throughout this course, we'll continue to expand your arsenal for select and for searching. You'll be able to do things like, I want all cats that are tabbies between the age of 1 and 2 and whose name starts with the letter B, let's say. So we'll be able to get much more specific, but for now, we're focusing on the basics. And as a side note, I want to show you that we will use where all the time. So it's not just for searching or for selecting, but we'll need to use it when we're updating or deleting things as well, because unless we're trying to update every single thing or delete every single thing, usually we want to update something specific. So we might say, I want to update the cats where their age is 2 and I want to make their age 3. Versus I want to update every single cat to have an age of 3. We could be more targeted using where. So we're going to start by seeing how we use it to select. So here's an example. Select star from cats where age is 4. So notice the syntax here. We have our same select star from cats. That will give us all cats. But then we have this where age equals 4. So what this will do is only select the data from the cats table where the age column is equal to 4. And if we try that now, if we look at our data, actually, you'll see we have 2 cats, Ringo and Egg, who are both 4 years old. So if we do a select star from cats, you see what we get. But now if we modify that with our where age equals 4, semicolon, we only get those 2 results. So we still get cat ID, name, breed, and age because we use star. That tells us the columns. But now we only have 2 results because we used where to get specific. One note, notice that when I refer to age here, that is the column, age. So there's no quotes around it. It's just age. So we can do the same thing here, but this time I'm using name to drill down or to get specific. So select star from cats where name is equal to egg. And notice I use quotes here because it's no longer an integer like age is. Name is varchar. It's text, so we need those quotes. So we can try that now. Select star from cats where name equals egg. Just like that. And you notice we get egg. Cat ID, name, breed, and age. One side note while I'm here. You may come across this at some point. What do you think will happen if I fully capitalize egg? It still works. So it's important to note that by default, this is case insensitive. So I could do lowercase g, uppercase G, and it still gives me the same data. So we'll see ways around this later on. Oftentimes it is useful though to not worry about case if you're dealing with things like an email address where case doesn't actually matter. So if a user types in their email with a capital letter at the beginning versus lowercase, it should still be the same email in your database. But we'll talk about that later. I just wanted to point out that it's a thing, case insensitivity. So that's all there is for now to the where clause. Now there is a lot more that we will be seeing and working with. Like I mentioned at the beginning of this lesson, we will come back and use where all the time. And in fact, we're going to continue to use it for updating and deleting. Like I said, we need to specify what we want to delete and what we want to update. But I just want to make it clear we're not done with where. There's a lot of add-on functionality that we'll see in ensuing sections. Perfect. All right, so before we go any further, we have a couple of quick exercises that are just going to test you basically on what we just learned, select, and where. So the first one, I'd like you to write the SQL that will select the following. And this is using our cats, so the same data that we already had, which is why I asked you to, hopefully you inserted the same cats. Basically, select all the cats, but only get their ID. And then the next thing I'd like you to do, of course, you can pause the video and do it, and then move on when you're ready to the next question, which is write the SQL that will select the following. Name and breed only. So we don't want ID, we don't want age, just name and breed in that order for all of the cats. All right. And the next one is a little bit more complicated. You'll need to combine both things we just learned, the select expression and the where clause. So in this case, you're going to only select the tabby cats, so the cats that have breed equal to tabby, and we only want name and age. And then finally, this is a little bit of a challenge because I didn't show exactly how to do this, but hopefully you'll be able to figure it out. We'll talk about it in the answer video either way, but hopefully it's not too difficult. In this case, what you're doing is selecting the instances where cat ID and age are the same. So if I go back to the data here, when I select all of them, if you look here, cat ID and age, they're not the same. 1 and 4, 2 and 10, but egg's cat ID is 4 and egg is 4 years old. And Jackson has an ID of 7 and is 7 years old. So how can you select just those two? And I don't want you to cheat. Don't select based off of their name or their breed or something. I want you to select where cat ID is the same as age. And we only want cat ID and age as well. Okay, solution video is coming up next. So let's see the answers here. Feel free to skip forward if you feel like you got them right. So the first one, write the SQL that selects the following. We only want the cat IDs, but we want all of the results, all the cats. So that will be select cat ID from cats. So we want all cats, but only the cat ID returned, and that's what we get. Next up, write the SQL query that selects the following. Name and breed for all cats. So it's similar to the last one, except we want name and breed from all cats. There we go, name and breed. Okay, so let's talk about the solution to this one here. We need to use both the select expression and the where clause. We want to select name and age from cats where breed equals tabby. So let's do that. Select name, comma, age from cats where breed equals tabby, just like that. And we get Ringo, who's 4, and Misty, who is 13, and that's exactly what we wanted to see. Now the final one is a little trickier, as I mentioned. We didn't see exactly how to do this, but hopefully you were able to figure it out because it's exactly the same syntax, but we're just checking a slightly different where clause. So we'll start with the first part. We want to select cat ID and age. So that's a select cat ID, comma, age from cats where, and we want where cat ID is the same as age. So we've been doing things like where age equals 2, or we could do where cat ID equals 1, but we can also just do where cat ID equals age. Those are both going to be numbers, and MySQL is smart enough to figure that out. So it's going to compare cat ID and age and see where they're equal. As you can see, we get what we want, cat ID and age, and they're equal. So let's go back and revise this a bit and do a select star, just so you can see exactly what we're working with. We have egg and Jackson, where age is 4, ID is 4, age is 7, and ID is 7. Okay, so in addition to having some practice there, we also learned that you can compare columns and the values rather than just picking an exact value like 4 or 10. We can compare two different columns and select based off of when they're equal to one another. All right. So one more thing we're going to talk about with reading data when we're talking about CRUD. Before we move on to updating and deleting, there's one other thing, which are aliases. These are really simple, very short video here. Basically, we can specify how our data should be displayed back to us. So what that means is rather than having cat ID, name, breed, and age here, I could tell MySQL that instead of breed, I want, type of cat. Or instead of age, I want years. And it won't alter the data itself. It just is how it's displayed to me. So let me show you a more specific example. Here we have using an alias. We're selecting the cat ID as ID. So rather than saying cat ID in the results, it will only say ID and then name from cats. Now this is not that clear why it's useful, and that won't become clear for a little bit because right now our data is very simple and straightforward. But once we have multiple tables and we're selecting from, let me give you an example. Let's say we have a pet shelter where we have a cat's table and a dog's table, and both of them have a name. So dogs have names, cats have names. And when we talk about join tables, which you'll learn about in a little bit, that's when we take both tables and we select from them at once and combine them. And the results, we would have two columns with name. So we would need to figure out which one is cat name, which one is dog name. So we could use this as to relabel it. So it wouldn't change the actual data. Our data is the same, the columns are the same. But when it's printed back out to us, when it spits out the data, it would use an alias. So if we try this now, cat ID as ID, comma name from cats, you'll see that we get ID here. And just to make that clear, I did the same thing, and I even put a little arrow pointing to that ID. It doesn't say cat ID, it says ID. So also just to prove this, we could do something like select name as cat name, or also just to show you, you can use quotes to add spaces. So cat name, like that, comma, we'll also select breed as kitty breed. Why not? From cats. And there you go. Our new column headers here are cat name and kitty breed. But of course, if we do a describe cats, you'll see nothing has changed. Our fields are still name and breed, just when we print them out. So that's all there is to aliases. You'll see us using them later on, but I wanted to introduce them now so that you're not overwhelmed with a bunch of new stuff when we get to join tables. Alrighty, so we've covered the C and the R in CRUD, create and read. Now we're moving on to the U, which stands for update. So how do we update or alter existing data in our database? We've inserted something and maybe we made a mistake. We want to change it, but it's not always a mistake. In our applications, let's say we have users, think about when you're updating your password. You forgot a password as a user, so you click the forget password link and you reset your password. Well, that needs to be changed in the database. Or you change your profile picture on Facebook, or you change your, relationship status or something. All of that requires updating. So how do we do it? And the answer is that we use probably the longest SQL command you've seen so far. There's multiple parts, but the keywords are update, set, and where. So we've already seen where. This is where we tell MySQL which items in particular we want to select to update. So in this case, this entire line here is going to find in the cats table all the cats who have a breed of tabby. And we're going to change that breed to be short hair. So again, we have update and a table name. Then set, and this is a list of the changes we want to make. So in this case, I'm setting the breed to be short hair. And then who do we want to, or who is the wrong way of saying it, but what do we want to perform it on? What is the actual data? In this case, breed equals tabby. So I will go ahead and just copy this line, move over here, and if I do a select star from cats, you can see that we have two tabbies right now, Ringo and Misty. If I paste this line in, update cats, change their breed to be short hair if their breed is tabby, and now we select star again, you can see that both tabbies, or previously tabbies, are now short hairs. Ringo and Misty. So here's another example. Let's say I wanted to change Misty's age to be 14. Right now, Misty is 13. And we realize that her dental records are wrong. Apparently you can tell how old a cat is from their teeth. So we misjudged how old she was, and we want to make her 14 now. So to do that, looks like this. Update the cats table, set age to be 14. We don't need quotes this time because we're working with a number, an integer. And we only want to do that if name is Misty. So let's try it. Now select star again. Or if actually we want to be more specific, we could do select star from cats where name equals Misty. Let's try that again without that extra L at the end. You can see Misty is now 14 rather than 13. The last thing that I'll mention about updating is that there's a good rule of thumb that you should follow. When you're updating something, you should make sure that you're targeting the right data before you actually do the update. So basically run the equivalent select using your where query. And once you make sure that returns the data you expect, then update it, just so that you avoid accidentally updating the wrong data. And the same holds true when we talk about deleting, which we'll do in just a moment. But the core idea is that there's no undo button. So you could update something back manually if you messed it up. But you always want to just make sure you're targeting what you mean to target before you hit enter on your update. All right, so it's your turn. We have a couple of pretty painless, I hope, update exercises. They should be pretty quick. So the first one here is to change Jackson's name to Jack. Once you've done that, you can move on to the next one, which is to change Ringo's breed to British Shorthair. And then finally, update both Maine Coon's ages to be 12. So there are two cats that have breed of Maine Coon, make them both 12. Okay, so in the next video, we'll talk about answers. All right, so the first one is to change Jackson's name to Jack. So we'll practice what I just talked about, running a select before you do the update. So let's just try selecting star from cats where name equals Jackson. Okay, so we get Jackson, but we want to update his name to be Jack. So now we do our update, cats, set name equal to Jack. That's what we want to change it to. And where do we want to change it? We want to change it where name is currently Jackson. Now I didn't specify that you had to use where name equals Jackson. You could also say where cat ID is 7, or where breed is Sphinx, because we only have one Sphinx right now. So any of those are valid. Now if we do our select again, we get nothing because there is no cat named Jackson. If we change it to Jack, we get the same cat whose name is now Jack. Next up, change Ringo's breed to British Shorthair. So let's do the same thing where we just do a select where name is Ringo. You can see that currently breed is Shorthair, but we want to get more specific, British Shorthair. So to do that, we do an update, cats, set, breed equal to British Shorthair, like that, where name equals Ringo. And again, you could also do cat ID 1, or where breed is short hair. You could identify this cat however you'd like, but let's make sure it worked. So now if I select where name is Ringo, we see breed is now British short hair. So the last one, update both Maine Coons, so breed equal Maine Coon, and make their ages 12. So let's just take a look at our current setup in our database. You can see we have these two Maine Coons, Cindy and Dumbledore. Cindy is 10, Dumbledore is 11. For whatever reason, we want both of them to be 12. So let's just select both of them first. Select star from cats where breed equals Maine Coon. Just like that. Perfect. So we are targeting them correctly, so we can copy that. And then we'll do our update, cats, set, age equal to 12, we don't need quotes, where, and I'll just paste that in. And it updates both of them. So that's really what I was testing here, is that you understood that where is not always just going to return one result. Whatever is returned will always be updated, which is also important to note that if you leave that where off, and I just said update cats set age 12, that would update every cat, which we don't want to do, which is why it's always important to select things first and make sure you know what you're targeting. Sometimes there could be reasons you wanted to update everything in a table, like if you were making a big change or you are migrating something, or you realize that you made a big error early on in your application and you have every piece of data is wrong somehow, maybe. But most of the time, you're being very specific in the changes you're making. So just to double check, if we select again, you can see Cindy and Dumbledore are now both 12, and that's all you needed to do. Perfect. Next up, we're diving into delete. Okay, so we've made it through the C, R, and U portions of CRUD. Now we finally made it to D, which stands for delete or destroy, depending on who you ask. So in this video, we're going to see how to delete things in MySQL. And it's pretty straightforward. It's very similar to selecting things, except rather than just selecting something, you're going to delete it. So let me show you what I mean. Here's an example that will delete any cat with the name egg in our database. So imagine, first of all, that we were selecting. All we would have is select from cats where name is equal to egg. So if we ran that, it would give us the cat or cats with name egg, and we can swap out select with delete, and that will delete it. So that same rule of thumb from before, where I said make sure before you update something that your selection is correct, then do the update, because it will, there's no undo button, unfortunately. Same holds true, and more so with delete, because your data's gone as soon as you delete it. So let's try this. We'll delete egg. Let's do, first of all, select star from cats. Just make sure we have egg in here. There he or she is. I'm not quite sure what I was intending with that name egg. So what we'll do first is just make sure we can select appropriately before we delete. So select star from cats where name equals egg. Remember that this is case insensitive. Just for now, I'll do lowercase just to prove that. All right, so we get egg. Perfect. So now to remove egg, delete from, and then we can just copy this. So before I hit enter, I do need to take a moment to address something pretty serious. And that is that no cats are being harmed, no cats are dying here. Yes, they're being deleted from this table, but in reality, deletion doesn't mean death. It means that they're being adopted, perhaps to a loving family that will treat them with the care that they deserve. So there's no death here, and I hope I don't receive any furious comments about how I'm treating animals in my course. I love animals. I learned from my first course, I made a mistake. I will never refer to deleting dogs or cats as killing them. I'm very sorry for that. So again, these cats are not dying. So with that out of the way, let's hit enter. Now let's go back and select star from cats. And as you can see, egg is now gone. Also, something that does come up sometimes, notice that the cat IDs have not shifted. They're still the same. Some of my students in the past have had the expectation that the IDs would alter, but they always will stay the same. And that's because when something is inserted into a table, that unique ID is generated for it. Remember, it's a primary key. And eventually, we'll learn about having multiple tables that interact with one another, and we'll be storing these IDs in other tables. So if it changed, that could be problematic because we'd have to change it in multiple places. Anyways, all I'm trying to say is that we removed 4, but we still have 5, 6, and 7. This didn't change to 4, this didn't change to 5, and so on. All right, so we deleted that. Enjoy your new life with your happy family, egg. So one last thing here is that if you look at what I've written here, delete from cats, what do you think that will do? Now, I don't run it, but what do you think this would do? And the answer is that it deletes everything, all cats. They're all released to their happy families. So that's important to know that you can do that. So it's different than dropping a table, because dropping a table gets rid of the table entirely and all data inside of it. But deleting from cats just deletes the entries in the cats table, but we still have the shell, we still have the cats table. There shouldn't be very many times when you need to use this command. I'm not going to do it just yet because I want us to have our cats data for a little bit for the next exercises, but just keep that in mind. Because we didn't specify a where clause over here, it's the same as selecting without a where clause. It selects everything, so this will delete everything. Okay, next up, you're going to practice deleting. All right, so it's your turn here. We're going to get some practice with delete. So we have 3 different things I'd like you to do. The first one is to delete all cats that are 4 years old. So if we look at our data, there's only 1 right now because we got rid of egg. But I would like you, so don't just say delete Ringo or where breed is British Shorthair or ID is 1, but use age. Then the next is to delete cats whose age is the same as their cat ID. Now I had to do something similar to this with the select exercises. Now you'll need to put that together with delete. So in our case, it's only Jack at this point. So Jack has an ID of 7 and age of 7. But once again, no cheating. Don't just select based off of name or breed. Do it the way I specified, please. I mean, it's up to you, but the way I recommend. Next up is to, oh my gosh, delete all cats. So that thing that I said I wasn't going to do because I didn't want to delete all of our data, well, you're going to do it. And then we'll be starting with a whole bunch of new data in the next exercise. All right, give it a shot. So let's talk about solutions to these. The first one, to delete all 4-year-old cats, all we need to do is start off, and you don't have to do this, but I like to start off by making sure we're selecting things correctly. So select star from cats where age equals 4. We get Ringo. Then I just like to copy this and do a delete from cats. And of course, I forgot to add a space, but delete from cats where age is 4. Now, if we do let's do our first select. We should see nothing. And if we do a select star, we should see that we're now missing number 1, who was Ringo, by Ringo. Okay, next up, delete cats whose age is the same as their cat ID. So this one involved something slightly different, like I mentioned, where we're not just checking for a specific piece of data like breed equals Maine Coon or age equals 12, but we're checking where cat ID equals age. So we'll do a select first, select star from cats where cat ID equals age, or you could do age equals cat ID. And we get Jack. Cat ID is 7, age is 7. Great. So then we'll just copy this and do our delete from cats where cat ID equals age. It says 1 row affected. If we try and select it again, it's gone. And if we do a select star, now we're also missing Jack. You can see we just have 2, 3, 5, and 6, which leads us to our final example. delete all cats. So this one is pretty straightforward. If we tried to do the equivalent select, it would just be select star from cats with no ensuing where clause. Just like that. So to delete all of those, well, it's just delete from cats. All of our cats are being released at once into a land of rainbows and joy. We hit enter here. They're definitely 100% not dying. Nothing bad will ever happen to them. Here we go. 4 rows affected. Select star from cats, the moment of truth. And they're all gone and not dead. Okay, so we've now covered the C and the R and the U and the D in CRUD. That spells CRUD, which means that we're done with this. Next up, we'll get some practice putting it all together. Hey, welcome to the next section. So this section is a bit different than everything else. I guess you could say that for every section, hopefully. But the structure is pretty different because it's all challenges. It's all exercises. So the way that this will work is you're going to practice all the commands you've seen up until this point. Everything from creating a database and switching and using the database to creating your tables and defining a schema, to then doing the basic CRUD operations we've talked about, creating, reading, updating, and deleting data. All that stuff, all those commands that are associated with that, you'll be practicing them all at once in this section. And it's not just one giant video. I broke it up into kind of logical, hopefully, sections that make sense. You'll go through the create section. We'll create data together, and then you'll do exercises with it. And we'll be working with all the same data, so we get all the same answers, which is really important that, if you're following along and you're trying to update something, that your update looks the same as mine. So the data that we'll be working with has to do with inventory management, has to do with, let's say, a clothing company, an online clothing retailer, or maybe just our closet. We're just doing an inventory of my closet. I need to figure out what fits, what doesn't fit, what colors are there, what shirts have holes, I don't know, what to give away to charity, what to burn in a pile, if that's what you do, all that stuff. And, we'll have different types of shirts. I got props again, short sleeves, we've got long sleeves, and the underappreciated and elusive 3/4 length sleeve. Not to mention things like, Hawaiian shirts, or even Hawaiian shirts of different colors too. I bet you didn't see that coming. Look at that, another Hawaiian shirt. Yeah, I should probably stop this video, huh? So let's get on with the exercises. Coming up, whole bunch of exercises around shirts. All right, so we've seen the basic components of CRUD, creating, reading, updating, and deleting. You've learned how to do all those operations in SQL. And now it's time for the super, ultra, hyper, mega CRUD exercise. Actually, let me try that one more time. It's time for the
super, ultra, mega CRUD exercise.
It's only been half a second, but I already regret that. So let's move on. So the idea here is that you're going to get to put all the different things you've learned to use. So this will be one exercise. In this case, we're working on closet inventory. Super exciting, I know. So basically the idea is that I or you or somebody has a bunch of clothing in their closet that they want to go through an inventory and figure out sizes and colors. And we're just focusing on shirts, so different types of shirts, tank tops, polo shirts, t-shirts, and so on. And we can go through and we'll just perform some basic operations on them. I do want to add a note that I know that up until now our data has been sort of trivial, and this included t-shirts. It's not that exciting or that realistic, really, but we still don't have the pieces to go into complex real-world data that you would see in a web app. But we will get there, and so hold tight. I promise we'll be seeing a lot of real-world, potentially more exciting, definitely more challenging data. So we're working with spring cleaning, and you're going to have a bunch of operations to do. And the first one is to create a brand new database. So think back to how we did that. No more working in the cats database. We need a new one called shirtsDB. So create that. And then the next step is to create a new table called shirts. And to do that, you need a little more information. You need to know, what does that table look like? So here you go. Here's a graphic representation. We've got a shirt ID, which cannot be null and is a primary key. We have article, which should be something like t-shirt or polo shirt or tank top. It's text. Then we have the color of the shirt, which is also text. White, green, black, blue, and so on. We have the shirt size, in this case, smalls and mediums, text. And then we have actually before I move on, I do want to call your attention to the fact that I did shirt_size rather than just size. And that's because size is a bit of a reserved word. So you can still use it, but it's a word that MySQL uses internally, size. And so it's better to avoid any conflicts there. So I just went with shirt size. And then last worn is a number, and that refers to roughly how many days ago the shirt was last worn. So the idea is that we would inventory our closet. Maybe you do this, maybe you don't, but you go through and you figure out what you don't wear all that often and then either sell it or donate it or, I don't know, make tie-dye with it, whatever you do. So that's what we're trying to calculate or what we're trying to store here. And it's just a number for now. So create that table. It should be called shirts. And once you do that, you can move on to the next step, which is getting the starter data in there. So I want all this data in the table, but I don't want you to have to type it up yourself. It can be obnoxious to insert that manually. So I've given you basically a starter seed data that contains the exact same thing. So a white t-shirt that's small with 10 days ago. So you can see it's the same as this first shirt here. And I've done it for all 8. So you could copy this. It's in the text of this video as well. And then what you could do is just insert it all at once. So remember how to do a multi-insert. Get all that data in there with a single line. And then the next step is to add a single new shirt. So insert something manually, not using a multi-insert, but just one at a time. A purple polo shirt that's medium that was last worn 50 days ago. All right. So then once we have those 9 shirts in there, we can now start to do some stuff with them. First thing we'll do is select all shirts, but only print out article and color. So we should only see t-shirt purple, polo shirt black. We don't want to see ID, we don't want to see size or last worn. Then once you do that, the next step is to select all medium shirts. So all shirts that have size of medium, and print out everything but the shirt ID. So we want all of this here, article, color, shirt size, last worn, but not this, but only for the mediums. Okay, then next up, we're moving on to update. So we've done the create and the read. We're working on update now, which is update all polo shirts to be size large. Maybe, I don't know, you realize that the company that makes your polo shirts, it might say medium on them, but in reality, they're pretty large. And so you want to update your database. It's a dumb story. Let's just go with it. So change their size to large. So that's where article equals polo shirt. Next up, update the shirt that was last worn 15 days ago and change last worn to 0. So this would mean there's a shirt that was worn 15 days ago that we decided to wear today. So we're going to change the database to say last worn is now 0. So once you do that, now our final update, we had a bit of a mishap. We were doing laundry. We took all the white shirts and we washed them with, I don't know, some colored stuff that we shouldn't have. And we shrank them at the same time. So we have a double update here. You need to update all the white shirts to now be an extra small size. And their color is no longer white, but it should be off-white. So you need to update both of those at once with one line, just to be clear. All right. Next, we're deleting. So delete all old shirts. And in our case, old just means if it was worn 200 days ago or last worn 200 days ago. We will see very shortly how you can do things like delete all old shirts that have been last worn greater than 50 days ago. But for now, we're doing exactly 200 days. Okay, next up, our tastes have changed. We've decided we no longer like wearing tank tops. We don't like the person that it turns us into. So we're going to delete all tank tops from our database. So delete all shirts where article is tank top. Then finally, catastrophe strikes. We have to delete all shirts. I'll let you decide why, but we need to delete all the shirts. That doesn't mean delete the table or the database. Just delete the shirts in the table, so it should be an empty table. Then finally, drop the entire shirts table, another catastrophe. So it should be an empty table at this point. drop it entirely. And that's it. So go through all those steps. I recommend just pausing the video as you go. Make sure you do them. And then if you'd like, watch the solution to see how to do it or how I did it. Okay. Alrighty, let's go through the solution. Spring cleaning, we're doing our closet inventory. And the first step was to create a brand new database called ShirtsDB. So if we hop over to Cloud9, if we just check what database we're using, remember we can do select database. We're using cat app. So we're going to make a new database, create database, and we wanted to call it shirts_db, semicolon. Now, if we do show databases, you can see we have ShirtsDB down at the bottom. All right, so the next step, we need to use ShirtsDB, just like that. And now if we run that same select database line, we're currently using ShirtsDB. Okay, so now this is probably the longest thing you'll have to type. We need to create a new table. We'll call it shirts, and it needs to have these 5 columns. Shirt ID, which cannot be null, and is a primary key, which means that we'll have it auto increment as well. Article, which should be varchar, and let's just for simplicity say all of these have 100 character limit. Color, varchar 100. Shirt size, yes, we could have kept it short, but maybe you might have a shirt size that's small, spelled out the full word rather than just the letter S. So we're not going to limit that either for now. And then last worn is an int. So let's try it. We'll do a create table shirts. And I'm going to do this on a new line here. And the first thing that we have, let's start with shirt ID, which should be an integer, not null, auto increment. Next, we're going to move on to article, which is a varchar 100. And then after that, we have color, which is also varchar 100. Then we have shirt size, which is also varchar 100. And finally, we have last worn, which is an int. Just like that. Then we'll close our parenthesis, and then we'll add our semicolon. And I forgot something, which I did not do on purpose. But if we look at the message, it says incorrect table definition. There can be only one auto column, and it must be defined as a key. And so I'm missing the primary key definition at the end, which this is actually a helpful error. Oftentimes these error messages aren't that useful, but this one tells us exactly what we did wrong. So I'm going to recall that line. And then at the end, I'm going to add comma, primary key. And then our primary key is shirt ID, just like that. Now if I hit enter, and would you look at that? I left off the last parenthesis again. So we have another error. Okay, so now if we hit enter here, it worked. If you'd like to see a nice cleaned up version of what this actually looks like here, I have it here. So create table shirts, shirt ID, int, not null, auto increment, article varchar, color varchar, shirt size varchar, last worn int, primary key, shirt ID, and the semicolon and the correct parenthesis closing it out, and that should do it. All right, and if we wanted to double check that things worked, we can do our describe shirts, and you can see we have what we expect. So the next thing is to get all of this data in our database. So I gave it to you as this comma separated list where things are all in the same format, where we have parentheses for one shirt, and then inside of that we have article first, and then color, and then size, and then last worn. So we can insert using that format. So we'll do an insert into shirts, and we have to specify we're doing article first, then we're doing color, then we're doing shirt size, and then finally we're doing last worn. And then we need our values, and I'm just going to hit enter for now, and I'm going to paste that giant list, and we need a semicolon at the end, and we hit enter. Good, no mistakes this time. It says records 8 rows affected. Okay, so if we wanted just to double check, we can do our select star from shirts, and we get the data in there that we should have. And then the last thing we need to do is to add a new shirt. So manually, one shirt rather than bulk inserting. It should be a purple polo shirt that's medium that was last worn 50 days ago. So I didn't specify what order you needed to insert into, so I don't really care, but we'll do insert into shirts, and we'll do color because that's how I specified here. Color, then article, then size, and then last worn. So color, article, shirt size, last worn. Like that. Values, and it's purple polo shirt, comma, medium, comma, 50. Just like that. Okay, and if we do select star, we should see that new polo shirt down there. It's purple, medium, 50 days ago we wore it. All right, so we've now wrapped up the create part of CRUD. We saw how to create the database. We created a new table. We inserted data into the table. Now we're moving on to reading. So this is the read solution. Basically, it's a bunch of select statements we're going to write. So the first one is to select all shirts, but only print out their article and their color. So back in Cloud 9, all we need to do is select, and rather than just select star, which gives us everything from all shirts, I mean, this is correct in that we want all shirts to be listed, but we wanted to narrow down the fields we get, which was article, comma, color. And there we go. Article color, t-shirt white, polo shirt black, tank top white, and so on. Next up, select all medium shirts, but only print out shirt ID. So that's all we want. So let's start off by just getting the medium shirts. So select star from shirts, where, and then we need to do a shirt size equals medium, just like that. And we'll hit enter. And we get 4 shirts that have shirt size of medium. But all that we want is everything excluding the shirt ID. Just a moment ago, I think I said it backwards. We want everything but the shirt ID, which means we need to list everything we want out. So select article, color, comma, shirt size, comma, last worn, and then we can just copy this from shirts where shirt size equals medium. And here we go. We have all mediums, and we have the 4 columns we're looking for, which excluded shirt ID. Shirt ID. So that's it for the selecting portion, the read in our CRUD. Next up, update. So we've covered creating and reading. Now we're on to updating our shirts. So the first problem is to update all polo shirts and change their size to be large. So we'll start by just selecting polo shirts. Select star from shirts where article equals polo shirt, just like that. Okay, so this is what we get. And what we want to do is change shirt size to be large. So we need to keep this. I'll copy it now. And then we'll type out update shirts set, and we want to change shirt size to now be large. And where do we want to do that? Only where article is polo shirt. Hit enter. We get 3 rows affected, 3 rows changed. Now, if we go back and run our same select, we should see all polo shirts are now larges. We could do the same thing just to see it in the grand scheme of things. There we go. We have 3 larges now, all polo shirts. The next problem is to update the shirt last worn 15 days ago and change last worn to be 0. So we'll start by just selecting that shirt like we did earlier, where last worn equals 15. There it is, tank top, blue, medium, last worn 15 days ago. And we wore it today. It was a hot day, we needed a tank top, and we want to update last worn to be 0. So update shirts set last worn equal to 0, where last worn is currently 15. We get 1 row affected, 1 changed. let's do our select again. We no longer have it, but now if we say select where last worn is 0, we have 2 shirts. This t-shirt that was already there and our blue tank top we just added. Perfect. So the final update is to update all white shirts, change their size to extra small, and at the same time, change their color to off-white. So this needs to happen all at once. You can't do 2 lines. I mean, you could, but that's against the rules for this problem. So let's start off by just selecting all white shirts. Select star from shirts where color equals white. Oh boy. Let's get rid of that extra L there. Here we go. So we have 2 shirts. A t-shirt that's white, that's small, and a tank top that's white, that's small. So we want to change color to be off-white and shirt size to be extra small because we shrank them and we mixed them with colored stuff in the washing machine, so their color is now off-white. So to do that, let's start with the first part, update shirts, and we'll set color to be off-white. And then we'll do the second part with a comma, shirt size equals XS, extra small, just like that. And then we'll do our where color currently equals white. And that should do it. Fingers crossed, no typos. Now, if we go back and select where color is white, we should have nothing. But if we say where color is off-white, we should have 2 that are extra smalls, or we could, of course, do select star from shirts. To check our work, we have extra small, off-white, extra small, off-white. Okay, so that problem was just making sure that you could update multiple fields at once, making sure you understood that. Okay, that's it for update. Next, we move on to D, delete. Okay, so we've made it to the end, the final video solution to our spring cleaning extravaganza problem. Now we need to delete. We've covered creating, reading, and updating, basically inserting, selecting, and update. Now we're going to use delete. So the first thing is to delete all old shirts, which really just in this case means last worn is 200 exactly. So when we do our select star, you can see there's 2 shirts that meet that criteria. 7, ID of 7, and ID of 2. But we're going to delete them based off of last worn. So we always start with our select star from shirts where last worn equals 200. And we get our 2 shirts. So then we can copy this. And actually we can copy this entire thing. Delete from shirts where last worn is 200. 2 rows affected. Now, if we do a select star, those 2 are gone. You can see it goes from 1 to 3, and then from 6 to 8. And there we go. So the next problem is to delete all tank tops. We've decided tank tops make us look kind of stupid, so we're going to delete tank tops. So your tastes have changed. So how many tank tops do we have? We've got 1 and 2 that are left. So we'll do a select star from shirts where article equals tank top. We get 2. Then all we need to do now is delete from shirts where article equals tank top. Hit enter. Now if we try and select them, they're gone. And if we do a select star from shirts with no where clause, now we have 1, 3, 5, 6, 9. So we've lost our 2 tank tops. All we have are t-shirts and polo shirts, which leads us to our final exercise here. Delete all the shirts. And I lied, it's actually the second to last. So to delete all the shirts, but not the entire table, it's pretty simple. We use the same where clause, which is to say that we don't have a where clause. So in this case, it returns select star from shirts returns all shirts. Well, we just replace that, delete from shirts, if I can spell it correctly, with this part, and moment of truth. 5 rows affected. Now when we do select star from shirts, we get nothing. It's a sad day. Not as sad as when we deleted the cats, but still sad. And the last thing is to drop the entire shirts table. We're just done with this. We hated this exercise. We want to move on. So drop table shirts. Now hit enter. And if I do show tables, no tables. And if I try and describe shirts, we get an error because there is no shirts table to describe, and it freaks out. So we've successfully deleted it. Now we have an empty database that we don't need anymore. And we're done with this. Congratulations. Hey, welcome to another one of these videos at the beginning of a section where I just make a fool of myself, do something ridiculous. This time, we're working with books. As you can see, I got more props. Just really love props on this course. And they're here for a reason, because in this section, we're getting introduced to our new data set. So for the next couple of sections, we're going to be working with one data set that I'm going to give you, and it has to do with books. And books make a particularly good data set because there's a lot of data to model. We've got things like, titles, genre, the authors, how many authors there are, things like reviews, ratings, page count, release dates, tons of information for all different sizes of books, giant prop books, medium, small books, all that fun stuff. And our backstory here, it's a very weak backstory, is that we run a small online bookstore and we're being just slaughtered by Amazon. So we're fighting back the only way we know how, which is redoing our database inventory management system. So that's what we're going to do. We're going to fight back by redoing our database, and that will be what we start this section doing. But then once we have that data in the database, we're going to move on to learning a bunch of new commands. And those commands all are called string functions. So I'll explain what those mean in just a little bit. I don't want to make this video too long, but basically they expand our way of selecting data and working with text or with strings. Really important and kind of fun things that we can do. So we're going to go ahead and get started. Before I forget, this book here, it's a very important book. This represents the book of SQL knowledge. Yeah, kind of regret this now, but this is the book of SQL knowledge. You can ignore, there's a bunch of bugs in here. They're attracted to the light. You can ignore that part. Our book of SQL knowledge doesn't have any bugs in it. We are bug free. Anyways, I think I should probably end it here. I'll see you in the next video. Okay, so we made it through all of that crud. That's sort of a joke. Anyways, we're now talking about string functions. So basically, we've seen how to interact with our database, create stuff, insert it, update, delete, all of that. But now we're going to focus more on select, or reading the data out. Because what we've been doing right now is just reading the data directly as it is. So I could say, I select breed and name from cats, and that's it. I get it back, and that's great. But there are things that I could do with that data. So with numbers, I might want to add them together, or I might want to, reverse a string, or replace all spaces with a certain character, or conjoin first name and last name, or conjoin, two pieces of data together. All of these are different operations, different ways of printing our data out that we can do. And so we're going to start focusing on them in this section. We're talking about string functions. So there's going to be a bunch of things that we see. I already mentioned some of them. We can concatenate words. We can take certain parts of a string and leave other parts out. We can reverse. We can uppercase, lowercase, replace characters, all sorts of things. But before we get there, the first thing I want to do is show you something that I think is pretty useful and that we'll use pretty often from here on out. So up until this point, all of the SQL that we've been writing has been manually entered into the command line, into the CLI here. So if I want to create a table, I have to type create table and then the name of the table, cats. But let's say that I mess it up. So let's say I typed singular cat, which technically isn't a problem per se, but it's a good idea to have things pluralized. It won't break. So let's say I don't notice for a little bit though. So I create a table cat, and we want, name is varchar 100, age is 10. What am I doing? Age is int, just like that. Let's say we leave it at that. Now this isn't a great example because this is a short line, but if I messed it up, I have to go all the way back here and edit it, right? And do cats like this. But let's now suppose that I have something even longer and I want to put it on separate lines and format it nicely like this. Create table cats. And then we have parenthesis there. And we'll do name is varchar. And let's say I misspell this like that. And age is an int. And then I realized, oh shoot, I totally messed up. I don't have a way of getting back there. I don't have an easy way of getting here. So I have to retype the whole line or copy it. There's no simple way of editing it. So what I want to show you is that we can run code from a file. And that's really, really useful. Running SQL files. That's what we're going to talk about here. So basically, by the end, we will be working with files that look like this. They're nicely formatted. They have nice syntax highlighting. We can edit them, make changes, and so on, and run them when we're ready, rather than typing things manually into the command line. That doesn't mean that we won't be typing things here, because it's a very useful tool. Oh, go away, Siri. It's a very useful tool. I should probably edit that out. Well, anyways, it's a useful tool that allows us to explore things, try things out. If they're short lines, it's great. But if we're really trying to do more serious stuff, it's much easier and better to work in a file. You can make edits, you can share it with people. So that's what we're going to do. So let's go ahead. Let me get out of this. And I'll just hit enter and get an error. And that's fine. So right now I'm in cats database. And if I do show tables, I do have a cats table, but if I look at it, it's empty. So what I'm actually going to do is drop that cats table, drop table cats. Okay. So what I want to do is remake the cats table. And what I could do is what I just did here, create table cats and do the whole thing. But rather than that, I'm going to do it in a file. And then all I'll have to do here is run that file. I'll execute it with one short line. So up here, I have a new file. Again, you can do file, new file. You can use the shortcut shown here. You can right click and do new file as well. Whatever we do though, we need a new file. And I'm just going to put something in there. So create table. And I am showing you creating a table, but we'll be putting any SQL query in here. Creating a table, dropping tables, inserting data, selecting any sort of query we want. So create table cats. And it's so easy now to format it nicely. We'll have name, which is varchar 100. Let's do an ID as well. See how easy that was if I made a mistake. Cat ID will be an int, not null, auto, increment, comma, name, varchar, and then we'll do age is an int, and we'll do primary key is cat ID. So this should all be review. But what's nice is I have this query like this. I need to save the file. So I did Command S, but you can also go File Save. And we need to give it a name. Any name will do. I'll just call it first file. And this is the most important part, .sql. So that's what identifies the contents of the file as SQL code. So we need that. Click Save. Make sure it changed up there. Also, you can see we got nice syntax highlighting now, which is also very useful. Okay. So I'm sure by now you can see the value in doing this. You have a history of your work. You can edit it, share it with people. It's just a much better way of doing it. So how do we actually run it? Well, this is the magic. Source, and then a file name. So in our case, our file name is firstfile.sql. So we just need source filename.sql. So I'm going to actually quit out of the CLI. And the first thing I want to show you is that it matters where you are when you initialize your CLI. So when I type ls here, and if you're not familiar with that, it just lists the current files. So what this shows me is that I have book data, first file, and problems. All right, so we want first file. Don't worry about these other two. So we are in the correct directory to access that file. So if I start up the CLI with MySQL CTL space CLI, and I use the cat app database, just like that, I'll make some space. Now all I have to do is source first file.sql, just like that, and we'll see what happens. It says query okay. So now how do we know it works? Well, we could do a describe cats, and here's our table. So that's all that there is to actually executing the file. It's just the source and the file name. But what I want to show you, two things. I'll go ahead and make a new directory. You don't have to do this, but I'm just going to call it, testing. And then inside of testing, I'll make a new file. And what I'll put inside of that file is a select statement. Select star from cats. Actually, let's do an insert. Insert into cats. And we'll just do, what do we have here? Name and age, which I'm just realizing I capitalized. So we could obviously go back and change that here and rerun it, but we'll leave it. So insert into cat's name and age, just like that. Values and name will be, let's do Charlie. And age will be, let's do an old cat, 17. Save the file. And we'll do file, save. And make sure the file has .sql in it. So we'll do rename. And I'll just call this insert.sql. Okay. Let's actually, just to show you we can do more than one thing at a time, let's insert both, or let's insert two, and this one will be called, I think we already have a Cindy. Let's do a Connie, who is 10. And then at the end, we'll also do select star from cats, just like that. So these three things will be executed at once, if we do it correctly. So now to reference this file, our CLI is running in this folder. So we can't just say insert.sql. If we did that, source insert.sql, it tells us it can't find that file. So what we need to do is do a source testing / insert.sql. And there we go. So that's important, that you have to access the correct path. You have to refer to this file by its full path to get there. So if you're in this folder, all that we can access are these. But if we drill to this folder, then we have access. And obviously you could extrapolate that to as many layers as you need. So now let's make sure it worked. You can see after it worked, we had query OK, one row affected. That was our first insert. And then the same thing, our second insert, and then our select statement gave us this right here. So that's all there is to running code from a file. It's really, really useful. We'll be doing it pretty much nonstop. And the first thing that we're going to do is actually get some new data into our database using this in the next video. So now that we've seen how to use source, we're going to take advantage of it to get some sample data going for the next couple of videos and exercises. Cats are kind of boring. They're pretty simple at this point, name and age and breed. And we need some more complicated data, and that's something that's a little more real world. So we're still not working with something straight out of a production app because we haven't seen some of the features that we need to know for that to work. So it's still kind of simplified data, but what we're working with is books data. So this is what we have. I've given you this file, so you can find it in the file section or the downloadable section of this video. Basically, there's two parts. We're creating a books table, and I'll go over that in just a second. And then after that table is created, there's a bunch of values that I'd like for you to insert. And I didn't want you to have to type these all at once, but I want us to all have the same data so we can be on the same page when we run exercises. So all of this data is actually real data. It's about books from Amazon. And basically every book has a book ID, so that should not be new. There's a title, it's a varchar. Then we have an author first name and an author last name. So if we look at one, here's the namesake, that's a title. The author first name is Jumpa, and her last name is Lahiri. Then we have the released year. So what year was it released in? And this is an example where we're using kind of the, I don't want to say dumbed down, but simplified version of data. Because typically you would probably store a date, an actual date, not just a number like 2003. So we'll see how to do that once we talk about dates. But for now, we just have 2003. And then the next thing is stock quantity. And this is just an arbitrary number I picked. The idea here is that we have a fictional bookshop, and we're keeping track of all the books and how many we have in stock. So for the namesake, we have 32 copies in stock. For a hologram for the king, we have 154 copies in stock. Then the final thing is the pages. How many pages are in that book? So you can see some books are really long, like The Amazing Adventures of Cavalier and Clay has 634 pages, and some are much shorter, like What We Talk About When We Talk About Love by Raymond Carver. Really good short stories if you like short stories. 176 pages. So a note about these books. I started off by just picking off the bestsellers on Amazon as of writing today. So I think that's where this one, Norse Mythology by Neil Gaiman, came from. But I then just decided to create a variety of years and page numbers, some of my favorite authors. It's a whole mix of things. So it is real world in a sense, but it's also I planned certain things to work certain ways. So we have we have some really long titles and some short titles. We have some really long books and short books. We have some books from the 2000s and some from the 1900s and so on. Basically, I wanted a variety of things that we could practice with. So go ahead, create a file in Cloud9 and put all of this in there. Now, if you want to type it, go ahead, but I would recommend that you don't, just so that you don't accidentally mess something up. We want our data to be consistent. So you go ahead, copy it, make a new file, and then we need to execute that file. And I want to make a new database. Right now, if we do select database, we're working with Cat App. I want to create database, and we'll call it Bookshop. And then use Bookshop, and we should have a blank slate. If we do show tables, there should be nothing here. Perfect. So what you want to do is make sure this file has been saved, and then we just execute it. So it's pretty straightforward. Source, and then you'll need to make sure you either are referencing the correct path. So in my case, I'm running my CLI in my root directory. So all I have to do is bookdata.sql. Whatever you called it, you'll need to refer to. I recommend just putting it in the main directory for now, but we could, you could have a separate folder if you wanted to, and you just need to refer to it correctly. Anyways, source bookdata.sql. And here we go. All right. First thing, we get this message, and that tells us the create table worked. And then we get 16 rows affected, and that tells us the insert statement worked. So let's just verify. Let's do a describe books. Here we go. Here's all that we created in that table. And let's just do a simple select star from books. As you can see, it's pretty messy. And that's deliberate. We're going to work on ways, we're going to see ways of refining this and making things shorter, collapsing data, and so on. So that's all we're doing in this video, just getting set up. Now that we have it in there in our database, we'll be able to work with it and be on the same page. Awesome. All right, so we have that out of the way. We've seen how to run files using the source command, and then we actually did that with the sample data that I gave you. Now we actually dive into the meat of this section, which is all about string functions. And the first thing I want to show you is that if you go to Google and we type in MySQL string functions, whoops, string functions, excuse that, and we hit enter here, you can see I've already clicked on this link, the MySQL reference manual, string functions. I have to say I'm not a huge fan of the documentation of MySQL. For one thing, I think it's kind of ugly and looks dated, but it does have all of the information you need. I just don't really like how it's presented. But if you look at this giant list here, these are all string functions that we can use. And a lot of them are very, very specific. I'm going to show you some of the more, first of all, the useful ones, and then a couple just fun ones, and that we'll be able to combine together for some good exercises. But we're not going to take a look at most of these. Most people don't even know that these are here. I'd say that's a generalization, but in my experience working with MySQL and people who work with MySQL, you use maybe 5 of these on a regular basis, and then occasionally you might need to do something like, hey, is there a way of doing X? Let me go check on the documentation, and oh, look, there is a way of doing that. Perfect. Or, oh no, there's not a way. Great. what am I going to do next? So I just want to show you that this is here. And the first one that we're actually going to take a look at is called concat. So what it will do is combine pieces of data, combine strings. So here's an example using this book data. Remember that we have author first name and author last name. And there are valid reasons for separating that data. Sometimes, you might want to sort books by last name, and sometimes you may only want the last name in certain contexts. You might not want the first name. It's not a great example, but there are reasons that you would separate this out. Just like when you're filling out a form online, you're signing up for a site, they usually don't just ask you for your full name. They ask you for a first and last name. But then if they have those pieces of information, it's pretty easy to combine them. So that's what we're going to see now. How do we combine these two and get something that says Jhumpa Lahiri or Neil Gaiman, or in this case, Foster Wallace as the last name, which I'm actually not sure if that qualifies as a last name exactly, but David Foster Wallace, how do we combine that? How do we get that? And the answer is we use concat. So let me just first show you what we have right now. We'll do a select author F name, author L name from books. And that's what we get here, just what I had printed out in the slides. So what we want, again, is to combine them, but we'll take some baby steps. And yep, here's a slide. I totally got ahead of myself. What if I want full names? So concat. The way that concat works is that we pass in multiple arguments or pieces of data, and it will combine them. So whatever we give it, in this case, if you had columns named X, Y, and Z, this would work, but it's really just supposed to be an example. More specifically, what you can do are things like this. Concat a column name with another column. So that's what we'll work on. We're going to do first name or author F name and author L name and combine them together. And if we do this right here, so concat author F name, author L name, what it will actually do is just slam them together. Put them exactly together, concatenate them. So there's no space in between. So we get Dave Eggers, Jhumpa Lahiri. So there's no, that's not exactly what we want. Maybe we want a comma. Maybe we want last name, comma, first name, or maybe we want first name, space, last name. So there's a way of doing that. When we concat, we can pass in a column name and then some other text and then another column name. And if we wanted more text, and we can keep going on and on and on, and it will concatenate everything. So to add a space, it's pretty simple. Author, first name, comma, and then a space, comma, author L name. And that will give us Dave Eggers and Jhumpa Lahiri. So now that I've shown you in the slides, let's take a look. And the first thing I'll show is that often people expect they can just come in here and just type concat. But if I just do concat, author F name, comma, author L name, there's a problem. Hopefully you can identify what the problem is. If I hit enter, this is not valid syntax. First of all, it doesn't know what table. What if we have multiple tables? Where's author F name coming from and author L name? And second of all, we have to select. So we can't just run these willy-nilly. We can't just run them on their own. We need to run them as a select. So select concat. And then in here, I'm actually going to start with something simple. I'm not going to use columns. I'm going to use text. So I'll just put something like hello, comma, world. So this is very trivial, but if I just do this, select concat hello world, and I hit enter, you can see it does it for me. And it just gives me hello world, combines these two things. So I could do the same thing and add a space. And rather than a space, let's do dots so it's easier to see. And we need a comma, a lot of punctuation going on. Select concat hello, comma, dot, 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 comma, world. It just shoves them all together and we get hello, dot, 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 world. So that's how we can do it with just text, which you probably won't be doing. You'll be doing things like this. Select, and then concat a column like author F name, and then a space, and then author L name from books. So let's try it. We can copy it now. Go over here and paste it. Select, and what it will do when we hit enter is just make a new column for us, or in our results. It doesn't change our initial data, just to be clear. Our data looks the same in the database. This is purely about printing it out. But we have this new thing up here with this horrible title, concat author fname, comma, space, comma, author lname. But then in here, we have the data that we're looking for. We have Jhumpa Lahiri, we have Patty Smith, Raymond Carver, and so on. So that's really useful to combine data like that. Now, if we want to get a little fancier, let's rename it. So let's give it an as, and we'll just say as full name, just like that. And now I get full name up here, Jhumpa Lahiri, Neil Gaiman, and so on. So that's concat. I'll show you a couple more examples just to show you how these string functions work. You don't have to just do one at a time. So we could do something like this. Select, and we'll do author first name just on its own, author fname as first name. Let's just do first, actually, as first, comma, author lname as last, and then we'll have a concat author, and let's do it on a new line just because it gets a little messy here. Concat author fname, so this is what we've already seen, with a space, comma, author lname as, and we'll call it full. So we'll have three different things printed out. The first name under the title first, author lname as last, and then the full name combined using concat as full. So then we need to say from where? From books. And now I hit enter, and I get this pretty little table. First, last, and full. So what I wanted to show is that you don't have to use it in isolation. You can combine it with other things, and we'll see this as we go. We're not going to just use concat, and you don't have to just use one concat per select. You could have multiple if we wanted to. I could have full name, and then I could have full names, comma separated instead. And if I want to do that, you can probably figure this out, but rather than just having a space there, I'll just put a comma. And now I get Jhumpa, comma, Lahiri. All right, so one more thing about concat is that there's something called concat WS, which stands for concat with separator. So there might be times where you're concatenating multiple fields, multiple things together with the same symbol or piece of data stuck in between them. So there's a shortcut for that. So if I wanted to have title dash author fname dash author last name, let's not debate why, but if I wanted to, I could do something like this. Select concat, and we have author, or actually we started with title, comma, and then we wanted to dash, and then author fname, comma, and then another dash, comma, author lname, just like that. So it's kind of a lot of repetitive typing, especially if we have more items that we're combining. But if I just do this here, from books, you see it does what you expect. It puts the title dash first dash last. But we can use concat WS, and it looks like this. So it switches things around a bit. The first thing that we pass in is what we want the separator to be. So in this case, a dash with a space on either side. And it will go ahead and then insert that in between every other thing we pass in. So we'll have title dash author, first name dash author last name. So now if I paste that in, you can see we get the same result, although I added spaces here, but it's the same idea. It's sandwiched every time. So just worth noting, if you ever are in a situation where you're combining lots of data in the same manner, you can use concat WS to save you typing this or whatever your symbol is over and over. So that's our first string function we saw, concat and concat WS. And what they do is concatenate or shove together, smash together strings. Next up in this onslaught of string functions is substring. So substring allows us to select individual parts or portions of a string. I only want the first character, I only want the middle 10 characters, or the last character, or so on. So the syntax is similar to concat. Here's an example. In this case, we're not working with columns or tables or anything. We're just working with static data, hello world. And what this will do, select, so there's our select again, and then substring, our string function. In parentheses, in this example, the first thing we do is tell it, here's the string we want to work with. So that first thing is hello world. And then what we're going to do is only print out the substring, the portion from 1 to 4. So those are indices referring to characters. And in MySQL, they start at 1. If you're familiar with other programming languages, they often start at 0. That's not the case here. So H is 1. So we go from 1 to 4. So 1, 2, 3, 4, which gives us hell. I'm sorry, that is a bad word. Please don't be mad at me. So hello world 1 to 4 gives us that, but that's not the only way of using it. Here's another example. Select substring hello world, the same starting piece of data. And this time, all we give it is one number, one index 7. So if we count 1, 2, 3, 4, 5, space is 6, 7 is that W. You might think it's only going to give us that W, but that's not true. It gives us from that W on to the end. So if you only pass in one number rather than 2, it starts from whatever that index is and just goes to the end. So let's try a couple out. We'll do a select substring, and we'll just do the hello world example that we just saw, and we'll go from 1 to 4. So we already know the answer here. Oh, there's hell. As you can see, 1, 2, 3, 4, we get hell. So if we change that from, let's do 3 to 8, we get low whirl. So that's one way of using it. And then the next way, as we saw, is if we just leave that second or that third argument off and we just say hello world, comma 3, it will go from the third character, so 1, 2, 3, to the end. So we get low world. Or in the case that I showed, if we do 7, we get world. And there's one more way that we can use it, which is to actually give it a negative number, negative index. So what do you think will happen? I give it -3. Hello world. Well, the answer is that we get RLD. So it starts from the end of the string, and it goes from -1 to -2 to -3. And it includes all of them. So RLD, if we try that, give -3, you can see we get RLD. And if we did -7, it would go 1, 2, 3, 4, 5, 6, 7 to this O. And we get O world. So that's how we do it with just static data. But now let's say we wanted to work with a column. So in our case, let's take the example of title. So let me just do a select star from, actually let's do select title from books. So we've got a variety of lengths of titles, right? Short ones like White Noise, Coraline, long ones like what we talk about when we talk about love, stories. Let's say I wanted to just print out, I don't know, the first 10 characters of every title. Maybe, you've probably seen that before when you're on a shop, and if there's a long title, the whole thing isn't printed out. There's just, a couple words and then ... or read more or something like that you can click on. We'll do something similar. So to limit this, what we would do, let's just take this as an example. We can do a select substring. We'll give it the whole title, and then we only want from 0 to 10, or from 1 to 10, excuse me. We could do that. And this actually, here's another error that I considered editing out, but I've decided not to because it is worth taking a note of. The problem is that it thinks that I'm still in a quote because I have this opening quote and this closing quote, but in between I have another quote, which is actually an apostrophe in this case. So this is not going to work. If I do this, I'll just exit out, just ignore that. But I'll have to redo the whole line, and rather than using single quotes, I'll use double quotes, like this. Where I'm calling from, selected stories, just like that. All right, and then I'll get rid of this other quote I put at the end. So that is important just to take note of. when we're working with strings, if you have a quotation mark in there, you've got to work around it. All right, so I do this, and you can see it gives me where I'm. Yes, this is 10 characters, maybe isn't long enough, but we're just going to work with that. So now to do it to every single title, it works just like we did with concat. We're going to do a select substring title, comma 1, comma 10 from books. And that's it. And there we go. Now we have this ugly heading up here, so we could do an as again, as, and let's just say short title, like that. Now we get this short title, blah, blah, blah. The name say Norse myth, American G, a hologram. Some of these actually work. The circle, there we go. Just kid. All right. So one other thing I'll show you. There is a shortcut. It's a very small shortcut, but you can type substr, S-U-B-S-T-R. I don't use this all that often because I can really remember what the shortcut is, because in some languages, there'll be substring where it's S-U-B-S-T. There's some I've seen where it's S-B-S-T. It's just not clear which characters get cut out, because it's not just all vowels, because we have a U still. Anyway, so if you would like, you can use this. I can just show you if you replace that. If we do select substring and just change substring to be substr, it does the same exact thing. But what I also want to show you is that we can combine concat and substring, or any of the string operators or the string functions you'll see. So let's say I wanted to add a dot, dot, dot after this, so that it looks like this. Short title, the name say dot, dot, dot. Rather than just an abrupt cutoff, let's add a dot, dot, dot. So hopefully you can identify what we need to do is first chop our string, use a substring, 1 to 10, and then concatenate that with dot, dot, dot. So I'll do this in a separate file. I'll go ahead and make a new file, and I'll just call it something silly like bookcode.sql. So we know we're going to do a select, and there's going to be a concat in there. And what we're going to concat is the short title. So again, this is wrong, what I'm typing, but I just want to put a placeholder. The short title with a dot, dot, dot from books. So this won't do anything right now. We need to replace this with how we actually achieve that short title. And that's going to be with a substring. So in here, we type substring, and we want to put title in there, whoops, comma, and we want it to go from 1 to 10. So this looks like a lot. It's pretty ugly. To format it a little nicer, we can do this. Depends on how intense you want to be about it. I like to just do it like this here. So substring is our first argument, comma, dot, dot, dot is our second one from books. So if you look at it, you can see the order things are going to happen. So substring is going to happen first for every title. So that will be the name say, or American G. And that will be concatenated with dot, dot, dot. And that will run for every single book in our database from books. So if we save that, we could either source the file or just copy and paste it. So let's do that now. We'll do source book code.sql. And there we go. The names say dot, 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 Norse myth, dot, 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 American G, dot, dot, dot. But you see we get this really hideous title up here. So let's put in as. We'll call it as short title. Save again, rerun it. Now we get this. Much, much nicer. Short title, the names say dot, 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 and so on. All right, so that's what all there is to substring. But the tricky thing, in my opinion, is just knowing that you can combine them. So it takes a little bit of getting used to, but again, the way it works is whatever is on the inside first will be evaluated. So substring will happen first, and then that will be concatenated with this. So that's it. We have a couple more, and then we'll do some challenges. The next built-in string function that we'll work with is called replace. And what it does is it replaces parts of a string. So if you wanted to get rid of a certain occurrence of a character, or you wanted to replace all spaces with commas or something like that, you could use replace. And the syntax looks like this. Here's an example where we have the string hello world. And you know what? I just realized this again. That's a bad word right there. So if we wanted to get rid of that, we could use replace hello world, comma, what we're trying to remove, and then what we want to replace it with. And it will do that to all occurrences. In this case, hell only occurs once. So that's what our output looks like. Percent star octothorpe. Oh, what's this thing called? There's an actual name for it. The @ symbol, but there's a real name. And then O world. So if I copy that over and just run it now, you can see that's the output that we get. We could also do something like replace hello world, and let's just replace all L's with 7s. Why not? And that's what we need to do there. And then we get hello world, but with 7s instead of L's. You know, we could do the same thing, just to show you one more, with O's and replace them with 0. Now, one thing that is important to pay attention to, let's say I have hello here with a capital O and hello here with a lowercase o. Or excuse me, world with lowercase. So the idea is just I have upper and lowercase O's in here. If I try and replace O, and let's say I just want to replace it with, let's do an asterisk. What do you think will happen? And the answer is it only replaces exactly this character. So it is case sensitive. So it didn't touch this capital O here. So that's one way to use replace. The other way that I mentioned is that it can replace multiple things. So here's a silly example where I have a string cheese, space bread, space coffee, space milk. Maybe it's a grocery list or something. And I want to replace all spaces with the string and, well, space and space. Basically, the output will be cheese and bread and coffee and milk. It inserted that right there, here, here, and here, every time there's a space. So if I try running that, you can see it works. Cheese and bread and coffee and milk. So now let's do something with the book data we have. We'll do something really simple and similar to what we just did. Let's replace all E's with 3's. And we'll just do lowercase e. So anytime there's a lowercase e, like namesake, Norse, American, we'll replace it with a 3. So to do that is a select, replace, and don't ask why. It's not really a real world example, but select, replace, we want to do title. And then what are we trying to replace? Lowercase e's. What do we want to replace them with? 3. And then what table? From books. And we could get more specific, but let's just do from books. And you can see we get the namesake with 3 3's and all the way down. Consider the lobster, cannery row, and so on. And that's pretty much it to using replace. A bit of a bonus at the end here is that I'll show you we can combine replace with other functions like we've already seen. We use concat and substring together. So we could try the same thing by using replace and concat, for instance. So I could do something like, if I work in this book code, I will comment this out, which I haven't shown how to do yet, highlight it, and on a Mac it's command /. On a PC, I believe it is control /. So I'm going to comment it out, which means it just won't run. It's here so I can see it, but SQL treats it, or MySQL treats it as if there's nothing there when it runs it. So what I want to do now, I want to combine replace. So what I'm going to do is select, and I'm just going to fill in some rough blanks here. So we have replace, and then we're going to have from books. But what we want to do is not just replace things. I'll do the same thing where we replace all E's with 3's. So that's replace title, the lowercase e with 3, like that. But I'm only going to take the first 10 characters like we did with substring. So I need to do substring, and I want to do substring of this whole thing. And I'm realizing as this goes on, This is a little convoluted, so I'll throw up another don't panic here. This is more just me showing you that it's something you can do, but it's not essential that you wrap your head around this entirely. But just to show you, so substring, and the first argument is replace this whole thing. So basically, we're taking a substring of this and then of this, and we want to go from 1 to 10. So that's a lot there. And now, if I paste it in here, you can see what it did was first replace all e's with 3, and then take the substring of that from 1 to 10. And of course, we could give it a better name because it is pretty ugly. So we could do as weird string, let's say. And now we have weird string up here. And yeah, that's pretty much it. I just wanted to show that we could combine them together. Why you would do this exactly, again, you probably wouldn't. But the key here is that they're kind of like Lego pieces. You can reorder them. You can, well, maybe more like nesting dolls actually, where you can nest them inside of one another. So like we did substring inside of a concat, we can do a replace inside of substring. So that's enough of replace. We're going to continue with a couple more, and then we'll do some challenges. All right, moving along to the next function, which is reverse. And reverse does what it sounds like. It reverses strings. That's why I said it's super straightforward. Forward, reverse. It's a joke. Yep. So that's what it does. It will reverse a string. So here's an example. Select reverse of hello world, and we get this. Ole. I think it's probably best if I just stop pronouncing them from here on out. But you get the reversed version of the string. Same casing and everything, same spaces, just reversed. And that's kind of all there is to it, to be honest. I'll show you a couple examples, but if you feel like you already have that was enough for you and you understand how it works, then feel free to just move on. But I'll go over to Cloud9 and show a couple of examples. So let's do a select reverse, and instead of hello world, let's just do meow, meow. Why not? Just like that. And we get what? Oh, I said I wouldn't pronounce them. Well, we get this right here. Reversed of meow meow. So we could do the same thing to find the reverse of every author's first name in our table, for instance. So that would be a select reverse author F name, and then from books. And there we go. We get the reverse of Jumpa, the reverse of Neil, and so on. And that's kind of it. And just like some of these other ones, we can combine them. So if I wanted to turn something into a palindrome, for instance, let's say I started with the string woof. And if you're not familiar, a palindrome is something that reads the same forwards and backwards. So the way I would do that is by adding FOOW to that and concatenating them. So taking the original string plus the reversed string and concatenating them. So we have two functions. We've seen how to do that. And it's just a matter of concat. So a select concat. And we'll just start with woof. And then what do we want to concatenate it with? Well, we want to concatenate it with the reverse of woof. Just like that. And that should do it. Let's try it out. And we get this. The palindrome version, I guess, that we just made, this sandwich. Now let's just try it with authors' first names again. So let's do that now. All we need to do is replace a couple things in here. So rather than concatenating woof, we're going to do author F name. And then we're going to use the reverse of author F name as well. Just like that. And then, of course, we need to say from where? From books. Let's copy that. So just again, we're taking the author's first name, the reverse of the author's first name, and we're smashing them together with concat. And there we go. We get, this one's kind of funny, I guess, David, Diva, D. And I don't think any of them are really pronounceable otherwise. But they are valid palindromes. So I guess we succeeded at something. The next function we'll take a look at is pretty quick as well. It's called char length. And what it does is it just tells you how many characters are in a given string. And that's pretty much all there is to it. So it looks like this, char underscore length. And when we do it on hello world, we could count the characters. So 1, 2, 3, 4, 5, 6 for the space, 7, 8, 9, 10, 11. And we get 11. At least my slide says we get 11. Let's verify that. Can't trust those slides. Whoever made them. Me. So you can see we get 11. So if we changed it and just added a bunch of stuff, we won't count it, but it says that's 31 characters long. Okay, so we could do something like select, and let's just print out the author last name this time. So author L name, comma, then we'll also side by side print the character length of the author's last name. So it might say something like Carver, and then next to that, 1, 2, 3, 4, 5, 6 characters. And Eggers, also 6 characters, and so on. So it's just going to be our author's last name followed by the number of characters in their name. So character char length, author L name, just like that. And let's put an as here, and we'll just call it length, just like that, from books. We'll hit enter, and you can see we get this nice little table with our author's last name and the corresponding length. So we've got a lot of authors who are 6 characters long, or their last name is 6 characters long, and then we get Smith, who's the shortest, and so on. We'll see later on how we could sort things and order them differently, but for now we've got them all here. All right. So just like before, if you feel like you have a grasp of this, feel free to move on. I'm just going to show that we can also combine character length. So what I would like to do is end up with a result that looks something like this. Eggers is, and then 6 characters long. So I'd like that for every author that we have. So if we break it down, this is going to be author's last name concatenated with is, concatenated with the character length, concatenated with characters long. So it's going to be kind of a big one. So let's try it out. We're going to do a select concat, and the first thing we'll concatenate is the author's last name. So author L name, and then we're going to concatenate that with space is space. So that gives us this right here. Then inside of that, we're going to add char length of author L name. You can see this is getting kind of long, comma, space, characters long, and our parentheses. So that's kind of a lot here. We're concatenating the first thing, the author's name, and then adding is, and then adding the character length, and then adding characters long. So we're building this sentence one piece at a time. And then we also need to specify from books. Okay, so let's take a look. Let's copy this, paste it in, and there we go. Lahiri is 6 characters long. Carver is 6 characters. Steinbeck is 9 characters. Foster Wallace is 14 characters. So that's working. By now, you should know we can use as to make this a little prettier. The only other thing that I'll take a moment to address is that this is kind of ugly. It's something that I do often to format my SQL, meaning my personal SQL, not MySQL, the database, is use one of these formatters. So there's a couple of them. I like this one, sql-format.com. And I can paste in my query and just click format. And it will just format it a little nicer for me. And it depends on, when things get really long, when we have long create tables, it will clean things up nicely for you. So in this case, this is the cleaned up version. Not that much of a difference, to be honest. But we can replace it anyways. It's a little easier to read. All right. So that's all there is to character length. That's all there is to char length. All right, welcome back. So we've made it through a lot of string functions. We've seen concat and replace and substring and reverse and char at. We have 2 more that I'm combining into one video because they're really simple and straightforward, and they're a natural pair. And then after we finish this, we have some fun exercises. So the 2 that we're looking at are upper and lower. And they do what they sound like. They change the case of a string. So we can make something all caps or all lowercase letters. So let's take a look. What do you think this will do? By now, you should be familiar with this select and then some string function. So select upper hello world is going to convert hello world to all caps. And just to prove that, let's go over here and do it. And we get hello world in all caps. Likewise, select lower hello world will convert everything to be lowercase. So it's really just the H and the W. And we get hello world. Still don't believe me? Okay, there we go. Hello world. So honestly, that's pretty much it. Just like the other couple videos before this, if you feel like that's good enough, go ahead, move on to the exercise. But if you want to see me use it with some of our author data, stick around. So let's do something silly like print out all book titles in all caps. So to do that, it's just select upper title from books. And that's it. And of course, we can combine it with other things. So we could do something like my favorite book is, as if someone was yelling. My favorite book is, and then a book name, like the namesake. And to do that, we need to combine the uppercase version. So I'll start writing it here, upper title. And we need to concatenate that with this string right here. And to concatenate them, kind of building backwards here, we need to use concat, just like that. So concat, my favorite book is, and we should add a space, the, and then the uppercase version of title. And then we'll just add a select concat from books. So I kind of built that one in a different way, starting from the inside out. But you can see we get my favorite book is a namesake. My favorite book is a circle. My favorite book is the Cannery Row. Yeah, I'm not sure why I put the there. Whoops. Well, anyways, if we delete that extra the and rerun this, now it's grammatically correct. So that's pretty much it to upper and lower. I mean, we could change this to be lower fine, if you make me, I'll show it. I don't think there's any surprise about what will happen, but just in case, it just converts everything to lowercase. Okay, so that's upper and lower. That was a lot of stuff. All these different string functions we saw. Now it's time for you to get some practice doing it yourself. Okay, so you made it to the end, hopefully. I mean, I guess you could have skipped forward, but you made it to this video, however you got here, at the end of the string function section. So we have a couple of exercises, and they range from pretty straightforward to reasonably complex, where we combine multiple string functions together. So let's get started. The first one here is to reverse and uppercase the following sentence. Why does my cat look at me with such hatred? I would also appreciate an answer to that, if anyone can help me. But anyways, what we need to do is just take this, you can copy it or type it out, and just use MySQL. I should specify, don't just manually reverse it and type it uppercase. I mean, using what you just learned, how can you reverse and uppercase this? All right. Then, when you're done with that, the next problem. This one's a little different. You don't have to actually do anything. I want you to figure out what this prints out. So don't just cheat and copy and paste it. You can do that to check your work, of course, but try and work through what's actually happening. We've got a select, we've got a replace, and a concat, and some words and spaces and symbols and dashes. So give it a shot. Then move on to the next one here, which is to replace all the spaces in book titles with this little arrow. It's a dash greater than sign. So replace every space. So instead of the space namesake, it's the dash, or let's just say arrow, the arrow namesake, and that happens for every space. And one more thing I'll call attention to is up here, it just says title. So you're going to need to use as to make sure it says title. So basically your task is to just get this same data printed out, this exact same format. Then after that, print this out. So you're going to have the author's last name printed regularly forwards, and then next to it, you'll have the same author's name printed backwards, in reverse, you might say. So that's what you need to do. Also pay attention up here, it says forwards and backwards. So you'll need to use as again to do that. Then once you do that, the next one, I'd like you to print out a full author's name. So it's a little more complicated in caps. So we want Jhumpa Lahiri, so that's author first name and last name combined and uppercased. And that should happen for every author. And then also again, the name appears, or the header says full name in caps. All right, then make this happen. So what this is showing is a title, the namesake, and then was released in, and then the actual date that we have stored in our database for when it was released. So you need to combine a title, was released in, and then the year it was released. And again, I called it blurb, but just put some label up there. Then next one here, print book titles and the length of each title, which is pretty similar to what I did using authors' last names. So just print the title and then the number of characters in that title. As you can see, some of them are quite long. The only other thing I would say is up here, pay attention, we have character count. So use as, you get it by now. Then finally, this one combines 3 different pieces of data. We'd like to have a shortened title. So I believe this is 10 characters, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, so the first 10 characters and then a ... afterwards and call that short title. Then we'll have the author printed out, but the way it should be printed is last name followed by a comma followed by first name. And then quantity. So quantity should not just be the number we have in stock, but it should be the sentence, 12 in stock or 104 in stock. So there's a lot of pieces here, and each one of these 3 is going to require multiple string functions to make it work. So give it a shot. This one is a little more challenging, so don't panic again if you don't get it, but try them all out. And then in the next video, I'll have solutions. Okay, let's go through some of these solutions. So the first one, reverse in uppercase this following sentence. Why does my cat look at me with such hatred? So I'm just going to copy it. And the first thing I'm actually going to do is make a new file. So I'll come up here and do new file, and I'll just call this exercises.sql. Then in there, I'll paste this. And we know that we need to do 2 things. We need to reverse it in uppercase. The order doesn't really matter. So we need to do a select first, either way. Select reverse, and we're going to select the reverse of this. And then we can do upper here, just like that. Or we could switch them and do select upper reverse. But let's give it a shot. And I'm missing my quote there. Let's get out of here. Missing that closing quote. There we go. Try it again. And there we go. It's reversed and all uppercase. So now I'm going to comment that out, and we'll move on to the next one. What does this print out? So let's start on the inside. Concatenate I with space with like space and cats. So it will be I like cats, the sentence with spaces. But then we have a replace, and replace is going to get rid of all those spaces and put dashes. So it should be I dash like dash cats. Let's try it. There we go. I like cats with dashes. So that one's really just testing that you understand how these are actually executed, and that you can stack or nest multiple functions. Next up, we have our first one really working with the books data. So replace all spaces in book titles with the arrow. So we need to do a select, and we know that there's going to be a replace, and we know that it's going to be from books. So let's start with that. So what are we replacing? Well, we're looking for all titles, and we're replacing a space with the arrow. Double check, replace spaces with arrows, that should be good. And the other thing was that up here we had title. So we need to use as title. So let's copy it, make sure it works. There we go, title, the arrow namesake, Norse arrow mythology, and so on. I'll comment that one out, and we'll move on to the next one. Print this out. So we should have forwards and backwards, and this is last name printed regularly, and this is last name reversed. So let's start. We know we need to have a select, and the first thing that we know is that we're going to have author L name as forwards. Just make sure I have that. So that will give us this right here. And let's close off. Let's do from books, just like that. So we could start with this if we wanted. And we get that left portion. Now we need this right portion. So we need a comma because we're now selecting two different things. And what we want to do here is use reverse author L name as backwards, just like that. Let's copy it. And there we go. Forwards, backwards, regular last name, reversed last name. All right, comment that one out, and we move on. This one, we need to print a full name, so first and last name of the author, all in caps. So there's a couple ways we could approach this. The easiest way is just to capitalize one string. So we combine the two, first and last, and then capitalize. If you wanted to, though, you could take capital first and then capital second, capital first name, capital last name, then combine them, and that works just as well, but it's easier to just do it once, and it's also faster. So the other thing is we have full name in caps up here, so we need to use as. So let's start by printing full name. So we have a select from books, and what we need to do is concat, and what are we concating? Author F name, comma, author L name. And I'll leave it like this for now, but hopefully you can predict what the problem is. When I do that, we don't have spaces. So let's add our space in. And that should give us the concatenated version. And, well, if we add the right comma. Whew. Now let's try it. There we go. So we get Jhumpa Lahiri, Dave Eggers, and so on with the spaces. So now what we want to do is just uppercase that. So we could do it on the same line because uppercase is so short. We can just say upper of that, copy it, paste it in. We also need to rename this up there. So we need as, and what did I call it? Full name in caps. So there's spaces in that. So we need to use quotes, full name in caps. Copy that. There we go, full name in caps. And if we wanted to format a little bit better here, we could do this. Just like that. And it will work just the same. Okay, let's comment that one out and move on. Make this happen. So what we have again is the first name, the title was released in, and then the year. So we're going to need to make use of concatenate. So let's start off with our select, and we'll have a concat, but we will also have from books, just like everything else we've done. So what are we going to concatenate? Well, first is the title, after the title, we have space was released in space. So we need those spaces, comma, like that. And we could just start with that if we want to take a look. And we get the namesake was released in, Norse mythology was released in. Then we just need to add in the year, comma, released year. And we haven't really worked with the year in a while, so if you forgot what the name of that column is, earlier when I was recording something, I ended up having to redo it because I was referring to year rather than released year. So you could just do a describe books and see that, okay, it's called released year. All right, so then we'll copy that in, paste it, and we get the namesake was released in 2003, and so on. The only thing we need to change is this up here. It's supposed to be called blurb, as blurb. And there we go. So if we're done with that one, comment it out. Next up, print book titles and the length of each title. So printing the title is easy. Then we just need to use char length and print the character length. So let's do that now. Select from books, and what do we want to select? Well, first we want title, and then after we select the title, we want char length. And one thing I should highlight there is that because this is a SQL file, you might have noticed I get these autocomplete suggestions. So I can either click or I can hit tab. And that's much faster in my experiences to hit tab. So we want the length of the title. Just like that. And we get the namesake 12, Norse mythology 15. And that's what we want, except we need character count. Just like that. However, this will cause an error. Whoops. We need to put it in quotes because there's a space there. Now we give it a shot, and it works. All right. Last one, I promise. So this one is more complex. 3 different things we're selecting. Each one is complex on its own. So let's tackle the first bit, the short title. So we want first 10 characters of the title plus ... So we'll comment this out. We'll do our same select from books. And we'll start by selecting the first 10 characters. So that's substring, or if you're lazy, whatever. Let's do substring. And we want it of title from 1 to 10, just like that. So that should just give us, at this point, you should know what it does. Gives us the first 10 characters, but we also want to concatenate that with ... So we'll do that here. Concat with the string ... not comma, comma, comma. We want ... And now if we copy that, that works, but it's supposed to be called short title. So we add as short title. And we just triple check our work. Looks good. Now we have our next thing we're selecting, which is the author, but we want last name, comma, first name. So it's going to be another concat actually, and we'll start with the author L name, comma, a comma in quotes, kind of hard to talk about, comma, 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 but this comma here is actually going to be concatenated in. This is quite a string to look at there. Author F name. And we want it to be as author. So we don't have to use quotes for that. Let's try it. See if we made any mistakes. It looks good. So we get Lahiri, comma, Jumpa, Gaiman, comma, Neil. That's what we expect. And it's called author. Good. Finally, we need this last portion, quantity. And this should be the number in stock followed by the string in stock. So if you don't remember what the column name is, we can do describe books. and you can see, okay, we have stock quantity. So that's what we want to use. So this time we're starting off with stock quantity, comma, and then we want space in space stock. Just like that. And then we need to use as quantity. Boy, it's a long one. So let's try it out. Make sure we didn't do anything wrong. And that looks good. 32 in stock, 154 in stock. And then we have author and short title both working. Now, one thing I want to point out here, that stock quantity is a number, it's an int, but it doesn't break everything. Concat is okay with numbers like this. What it does is it just takes the string version, the text version of 32, and adds it to in stock. So it basically does this. 32 plus in stock. So that's very different than trying to add a number to text. All right, so that was a lot, I know, but we're done now. We're done with these string functions, and we're moving on.